Am I on? You hear me now? Yes. Good morning and welcome to Signaling Design Automation Forum in Stockholm 2025. This is maybe the 6th time we're running this conference, with a few exceptions during the pandemic and so on. My name is Anders Lindén and I'm the CEO of Prover, and I'll be very, very short. Why are we doing this? Well, at Prover we strongly believe in trying to find new ways of automating everything around signaling system to achieve faster, safer, and more cost-efficient signaling systems. And to do that, you try to kind of push the barriers with new technology. So we want to inspire and also be inspired by the attendance. And new technologies like AI or using digital twins all sounds very nice, and it is. But that aside, in the day-to-day work, we also do things that work well and some things that might not work as well. So sharing best practices is also one of our keywords for this event. And even if in this super digital world, we also strongly believe in meeting in person, networking, building relationships with peers, competitors, colleagues, partners. So those three keywords have been kind of our guiding stars for SDAF, which we call it during the day. I will not talk very much more than this here, but I hope everyone will enjoy the day, and both on site and online. And Mats, my colleague, our VP Business Development, will be your guide during the day and lead you through the day, introduce the presenters and everything else. Thank you.
Thank you, Anders. So good morning, everyone. Again, you're all welcome to this event. Like Anders said, I will be the guide. We have today here in the room 50 participants. You are listening and you're also active in this way of asking questions, have a dynamic environment here. We also have about 100 people online. You online, you're able to be part of the conference by asking questions in the chat, listening to the presentations, and you will be supported by that. Also, you audience in here, when you ask question, you need a mic to involve the people online as well. So we will be sharing the mic when you have some questions. So that's how we work. I do some practical things. We have Amanda. Could you just wave? If there are any practical questions, please ask Amanda or someone in the team. And we have Kahina. You will be running the chat and the questions from the chat. So questions goes there as well. Otherwise, I like to present the agenda. The agenda for today is we started to talk about the Open Signaling Initiative. That's Jesper doing that before the coffee break. And then we will have quite an interesting journey together with Trafikförvaltningen and also how things are happening in Trafikförvaltningen. The next speaker from Cactus will talk about the projects ongoing in Stockholm Metro with Trafikförvaltningen and how we have worked with that project together. We take us down also to the actual hardware and how do you run the hardware. We, as Prover, has always been working with software, but this needs to be run on something, and we get support here from Schneider to present what they are doing in the industry. Then we have lunchtime, and then we jump to Germany, and first we jump to Switzerland, and we have TUV SUD from Switzerland, Henrik, talking about their work with ERTMS, data verification, and how they are driving their digitalization of the railway forward. We will then learn more about the EU-LINX project. EU-LINX is a standard for how to connect systems in the signaling industry. And we have experts from Germany, Robert and System Labs 21. Then it's coffee break, and after that we have a session around AI, a hot topic, and how should we adapt with that in signaling, and especially we that are doing safety. So that's an interesting end of the day, and we end with the panel discussions. Then we have something for you in the room. You online will not be part of the evening actually, but you're invited for next time. So I can already say that you should be here. Great. Any questions in the audience right now? No, I think we start, and I hope you will enjoy the day, have good talks and meetings with each other, and be part of the presentations and questions. I should also mention that we have a small exhibition in the back, where we have 5 exhibitors exhibiting their different tools and products. Please have a look and talk to the friends in the back and learn about how they are doing building signaling systems. Yes, I think I now hand over to Jesper, who will talk about our new initiative, Open Signaling. Please, Jesper.
Thank you, Mats. Yes, we are working with an initiative that we call the Open Signaling Initiative, and I will tell you a bit what we are doing and why we think it is needed in this domain, and also how we came to this, because Prover has a history of observing difficulties in the domain that could be resolved in this way. Prover has a very long experience of verifying and validating signaling systems. We also started when we observed that one of the problems with verifying and validating systems can be that they are not actually well designed, or there are needs to improve the design. We also started products for aiding the design work. And so this was code generation. And when we presented this in particular to infrastructure managers and infrastructure owners, they were usually enthusiastic, saying that this seems very nice, but you only make software. You need to also start doing hardware, because we can't buy just software. We need to buy an entire system with hardware and software and so on. And that's kind of frustrating, because this is not how it works in other domains. You can perfectly well work as a software supplier and just buy some, or ask your client to buy some hardware, and then you produce software. So why is this the case for rail? It would also mean that we just became yet another supplier, the kind of supplier that we wanted to compete with this idea of producing software. So instead of solving something, we would just jump on the same solution as the other ones and become a competitor of theirs, which is not very attractive. So if we don't want to do hardware, that's not what we want to focus on. We thought, okay, so let's find some proper hardware out there, so we could at least recommend. You can use our software, you could use their hardware, and we can then work together. Unfortunately, when we started looking, we couldn't find any good solutions, because either this hardware was from one of the big suppliers and strongly connected to their software, or it wasn't good enough, lacking safety cases, unsure how it would work, not open enough, making it impossible to understand exactly what it was doing and so on. But now we have observed that this has changed the last years. We have Schneider here, for example. They have a SIL4 certificate for their hardware. We have NEAT in the corner there. They couldn't be here because there is an expo in Italy, their home country, that they needed to focus on. But they have sent some equipment, an interlocking computer, SIL4, with our software on. And there are also others like HEMA, German company that's doing SIL4 controllers, and there is also PILS. So there are some possibilities now to find, you can find COTS, so commercial off-the-shelf computers that you don't need to design from requirements. You can just go out there, find them on the shelf, buy them, install them, run our software. We also see that infrastructure managers are becoming more curious than now, since those computers have existed a few years, and now some interest is growing among infrastructure managers. So we thought, okay, if this isn't a thing, it's not out there, this concept isn't a thing yet, but we would very much like if this happened. So let's make it happen. So we have this program where we now, I put some of my time on finding partners and convincing them that they could be part of this. We have a website where we present the partners who have decided to join and so on. So I will give you, you can have a look at the website later. You will have my last slide is about how to find that one. Okay, so we don't only want to find hardware and load our software on. We also think it's important that this hardware can be replaced. Because that's another issue, that if you buy hardware, you might ask, okay, but what in 10 years, maybe this hardware will break and I will need to buy a new one. I must be sure that I can buy exactly the same hardware again. Well, why is that so important to you that you need to buy exactly the same hardware again, if you think about it? It's because that's my only guarantee that it will still work. But that's not how we want it to be. We want it to be possible to replace the hardware with something better that exists in 10 years and still be sure that everything will work. Okay. So we need, and this is not only for the hardware, we want to be sure that also the software can be replaced in 10 years and still work on the hardware. And we want to know that if some small component that, I don't know, make a detection of the switch, if that is out of, that is not possible to buy anymore, you can replace it with some other component that makes the same job. That should be possible. So to achieve that, if you look at any other domain like mobile communication, it's perfectly okay to replace an Ericsson router with a Huawei router. It will still work. People can use their phones. And this is, of course, how it should work also in our domain. So we need to be able to replace components. And to do that, we need to design systems in a way that ensure that they are independent, standardized components in the system, and that they can be mixed and matched. So as opposed to when you buy a system from one of the big suppliers and get everything from axle counters to computers or software or even traffic management system from the same supplier. That's the monolithic old way, and the new open way would be to have independent components. So this also requires that the components from different vendors can work together. So otherwise we are back again to this monolithic idea. It must also be possible to upgrade and maintain these systems. And integration, so the task of putting everything together and make sure it works, must be possible to do by any engineers, basically. Which also requires that the documentation is very good, so that the integration engineers can read and understand what the components are doing and put everything together. Sorry. So 3 key principles that I try to remind myself on when I work on this, and I think it's important for everyone. One is open interfaces, another one is loosely connected components, and the third one is COTS hardware. So on the open interfaces, that's to ensure compatibility with multiple available components that are available today, but also in the future. Because in 10 years, when we replace something, there might be other components available, and we want to be able to use them. So standard interfaces become very important, and there are some standard protocols already out there. OPC UA is pretty well known within the PLC domain, so supported by Schneider, for example, but also by competitors like HEMA. So it has become a de facto standard. Well, it is also standard. There is some work ongoing to also make a new version or make something around OPC UA that will make it good enough for today's cybersecurity demands, because OPC UA was not designed with cybersecurity in mind. But this is about to be solved. Then there's MQTT that is very big in the Internet of Things industry. That's a way of you put all your data in on a server or on it's called a broker, and then various subsystems can subscribe to the data they want to have. So it's a kind of data lake paradigm around it. Very big, and there are built in. It's easy to find, for example, a library in Python that can speak MQTT. There is also ULinks and Rasta, and Robert from Systems Lab 21 will talk about that later today, because ULinks Rasta is a European initiative for the rail domain. ULinks is a standard on how the various objects are supposed to not solve their problems, but the kind of interfaces they are supposed to have, and Rasta is a communication protocol. Then we also have some standard formats for configuration data, for example, Rail ML, with some other alternatives as well. So there are emerging standards. And then on the loosely connected components thing, that's because we want to be able to replace component by component. So if something breaks, we don't want to remove the whole system, but just fix that component that is broken. It's also then important to separate the platform from the logic. And with the platform, I mean the hardware, but also the operating system on the hardware. So the hardware always comes with an operating system that will do memory checks, that will handle inputs and outputs and communication and so on. But then you need to load some logic on the platform for handling a particular station, for example, or a particular specific application. And we are experts on producing logic for signaling systems, but we are not experts on the operating systems and the hardware. So we think it's important that the hardware suppliers, the hardware comes with operating systems and we come with logic, and it should be possible to replace our logic with someone else's logic, or take our logic and load it on a new platform 10 years later if there is a better platform. So we need clear separation of this. Avoid independence between hardware components. That's also, I think I already covered that. If you buy a whole system from one supplier, they might have a lot of dependencies. For example, saying our switches require our object controllers, and they can only communicate with our interlocking that can communicate with our radio block center, and so on. That's not how we want it to be. It must be possible to replace component by component. Okay, and then of course with the COTS again, it's commercial off the shelf. So the idea that we don't make computers when we need them, we just buy them, and that's of course important for competition. So if you have something, if you have a project where you want to have some hardware, you can go out on the market and say, I want hardware that complies with this standard, a PLC standard, for example, or some other standard, and you can buy them off the shelf. Not only computers, but also relays or other components that are available there. It's also to make it possible to maintain the system in the long run. You have a small storage, but then when you're out of stock, you can just buy new ones and put on your shelf. So for this, we have also been thinking who will want this. So what is our target market for this kind of signaling systems? We want to at least start with secondary lines. We think that the prestigious projects, big lines and high speed and so on, will probably still be covered by the big suppliers, because it's very expensive, so you can also afford to use to buy a rather expensive system from one of the big suppliers. And buying from someone big is also gives you some security, because you trust them more if they are big or whatever. But also because the big suppliers are noticeably less interested in smaller lines. We see this happening. They are merging, they are becoming bigger and bigger. We only have in Europe now Siemens, Hitachi and Alstom, and they are bidding on whole countries, like we want Norway or we want Finland. They are looking for very big projects. And so when Siemens won Norway, they built an entirely new building for the engineers doing Norway. That's how they work. So we also see that they are becoming expensive for secondary lines, probably because they are not that interested in the secondary lines. It's too small for them. So we have a market opening here on the secondary lines. We also think that this solution is super good if you have something already and want to migrate. So typically you have a relay-based system. We have in Sweden over 600 relay-based interlocking systems, and it's the same everywhere, it seems. If we, relays were built in relay-based systems, started building 60, 70 years ago, and are still being there. They still function, but they have also been, they are newly built ones. But it's also a natural question to ask, okay, do we want to continue with those relay-based systems? It's difficult to find young engineers who learned how to do this. It's also sometimes a problem to find the components. And well, it's just old-fashioned. So it's nice to have a computer-based system, because you can, for example, change your signaling principles by just loading a new program on the controller. So you can improve, for example, how it works by just software, and that cannot be done with relays. If you want to improve something, you need to rewire and put in more hardware and stuff. So migrating old things to new ones, and then also extending existing lines. So if you already have a line, a metro line or a train line with some system, it can be relay-based or computer-based. You want to extend it, then most will want a system that works in the same way. So they want to extend, but have the way it works very familiar to traffic managers and so on. If you go to one of the big suppliers, they will propose to you that you replace everything you have also on the existing line and say, we have a super good system. You install this on your home line and you will have high performance and better capacity and so on. But this comes with problems. Well, it will be expensive, but also you will need to train your traffic managers in those new principles, and you will have to train your drivers, your maintenance personnel, everyone. So being able to offer, you can have a signaling system that behaves as you are used to, and all your staff will feel that this is familiar, that's attractive. So for the infrastructure manager, the one who is the end customer in these projects, is also very, very attractive that they become more in control, because they can tell exactly which system they want, and they can also ask for changes. And if this is modular enough, then they can ask for changes in a market with competitors. So they can, if the original supplier gives a very high, it's a very expensive offer, then you can ask your favorite engineering firm, can you do this? Because they want a lot of money. Or a public tender with competition and so on. So very attractive for infrastructure managers. more, if you think about it, this becomes more like it was with the relay-based systems, that you don't have a supplier that owns the system. You own the system yourself, and you can ask the market for changes. And also, after changes, it will be simpler to make a new safety case. The traditional way of doing a monolith makes a simpler safety case when you do it the first time, because the safety case can refer to, well, we know that this will work because this components take responsibility for that, and it's well tested together. We have done hundreds of projects with this particular architecture. We know it works. So that simplifies the work when you start a system. But when you make a change, there is a problem that the safety case was also very monolithic and with lots of references between components. So if you make a change, the supplier will argue, now we need to redo the whole safety case because it was created in a system perspective, and now we have a new system, so we need to redo a lot. I'm not claiming that this problem will go away with open signaling, but I think that a modular approach, as with open signaling, will also make it easier to replace one of the modules here, or one of the components, and argue that this will be safe, as long as you need to argue that the interfaces are respected and so on. Another aspect that I think is important for end customers is that project risk will be lower, because when you have a monolith and you make a change, you usually change a lot at the same time. You might replace a system with a new one after 30 years, and then you throw in also a lot of improvements in the process. So for example, you have a traditional system, now you have CBTC or ERTMS. So you throw in a lot of changes in the same project, and this becomes a risk because there is a high likelihood that something will take longer than you thought, or will be not as good as you hoped, and so on. And by a very modular approach, you can make small changes. We add this switch, we change this, we add a new feature that will increase capacity, and you make small changes one after another. So there is no need to plan for a big bang project where you replace everything. Okay, and of course, sustainability. Instead of throwing out and crashing what you have, you just evolve. Something that might be, I mean, the infrastructure managers, they usually do public tenders, and this requires that someone answers to the public tender. And it's not possible to answer as a hardware supplier or a software supplier. You need to answer as a system supplier. And one way of doing this, of course, is to answer as a system integrator. So someone out there needs to say, we are prepared to take on the role of system integration, and we will find hardware and software and so on. And we will make sure that you get a system. Then the system integrator can offer to also provide a maintenance contract for the years or whatever. But the point is that the infrastructure manager is not bound to accepting that offer from that system integrator. Someone else could maintain the system. Of course, it's more attractive in a way that the infrastructure manager buys separately from the market. This does not go well with a public tender concept, but I think it would be possible in, for example, if you want a new version of the system. Say that the hardware has expired, it's old, it needs to be replaced, and you don't need to replace the logic. Then, of course, you can just ask someone to provide new hardware and maybe do a little system integration work. So you will still need a system integrator, but it will not be the prime contractor in this model. So this project model is actually something that Trafikförvaltningen is trying. So I guess Andreas and Kristina might mention this, which is a very good idea, I think. But I would also bet on the other model being more common out in the future. Regarding open interfaces, I must mention some standards that exist. CENELEC is familiar to everyone working in the domain of rail and metro. So that's obvious, we need to follow CENELEC, but there are also then there's a standard for PLC controllers. So this IEC 61131 that the red Schneider PLC complies to, for example. There are some promising data formats such as RailML for track layouts and geographical data. There is LCF that we developed some 12 years or so. That's a JSON-based data format. We think it has some advantages over RailML because the LCF files can be manually reviewed, so you don't need to develop a tool for checking the data. You can actually do manual review if you prefer, which is good in some cases. And there is also RDF. That's a format by the W3C consortium, so it's World Wide Web technology, semantic web technology, but it has been embraced by some European rail initiatives. So I think Trafikverket is basing some of their data on RDF, and there is also ongoing work in other countries in Europe on using RDF as more as a competitor to RailML, I would say. And then there are lots of communication standards. I mentioned a few of them before, and I will not mention the other ones. The problem is not the lack of standards. The problem is probably that there are so many standards. It would be very nice with just one standard on communication, but we are not there. I think this ULINX Rasta has the ambition of becoming the only standard used. Okay, so what can we offer then in this if you want to build an open signaling system? We think it helps a lot with formal specifications that we are good at. And that's because if you have formal specifications, you are sure that the logic will be well understood and separate from the hardware, from how the hardware works. We are also used to working with formal development that includes, for example, having digital twins and simulators and formal verification in the loop when you develop your system. So this is very important because if you want to replace the hardware at some point, you want to be sure that the software that you develop is vendor agnostic. So this logic that you have can be loaded on a new piece of hardware. So you don't want the logic to be entangled with the choice of hardware. You want the logic to be agnostic to that. Formal verification, I hope that everyone here knows what it is because it's our baby at Prover doing formal verification. Just briefly, it's about creating a mathematical model and proving properties about it. So you model your system and you prove properties. So instead of testing, you can do testing as well, but you can solve some problems with formal verification. If you want to ensure, for example, that a certain signal cannot be green if a switch is out of correspondence, you can try lots of scenarios. But you can also simply prove this with mathematics. So you build a mathematical model of the system and you prove a theorem about this, saying that this signal will never be green if the switch is out of correspondence. And this gives you 100% coverage. So you don't need to worry that you might have missed some corner case when this can happen. You know that it will never happen. That's the beauty of this. And also because it's totally automated, it's possible to rerun the proof in the future. So if you need to make, if the change of the hardware leads to some change in the software, it can be, for example, that you have a new, the new hardware will execute your logic in a slightly different way. Then you can change the model according to the new hardware and rerun the proof and be sure that the logic is still safe even with the new hardware that you will be using. We are also now quite proficient in the various signaling principles out there. So we are a Swedish company, so we know Swedish principles very well, but since a very long time we have a branch in France, so we know the French market very well, but we also worked with American, British, Chinese even signaling systems, so we know how it varies over the world and can help out basically anywhere. And also in this, to make things work together, there is still a lack of standard, meaning that there is a need for translating data and translating protocols between equipment, and we are experts on that as well, so we can help out with that. And we have some experience, or quite a lot of experience, on the Senelec standards also. So that's just to say why we think that we can, we are a natural player in this open signaling area. I want to mention a few examples of ongoing projects just to make this a little bit more concrete. We have a large depot in France where so the signaling system will be delivered by Eiffage, one of the Eiffage companies. Eiffage is a very large group of companies, and they have one that is actually on the energy side mostly, but they have taken on to make a signaling system SIL 4 for this very large depot. And here we are doing signaling design automation, so we are using the tools ProverILOC, or providing them with tools ProverILOC for the design work, Prover Test Bench for running systems tests, automated systems tests in a simulator mode, and a Prover Certifier that will provide an independent formal verification as part of the safety evidence. So the safety case will be based on some testing, but also on formal verification, which is very good because this formal verification can decrease the testing you need to do a lot. We have a quite similar project ongoing for SL, Stockholm Metro, where so SL is the owner, but the infrastructure is called Trafikförvaltningen, and Andreas and Kristina are from Trafikförvaltningen and will tell about this. So it's the same thing. We are using ProverILOC and Prover Test Bench and Prover Certifier. And there will be some testing, but a lot of formal verification also to base the safety case on. And then the next customer will most likely, so we are still discussing, but it's looking like we will have this project in Australia. So it's nice to cover the globe early. It's the same thing. So we have made a proof of concept with them, and we are now discussing to make something real in Australia. The same technology stack. Okay. So this is just a summary, basically, the vision we have now of this open signaling. So what we want to achieve is a rail and metro signaling domain that is more open, so more like IT domains, where we have a good separation of hardware and software and of various components, so that the infrastructure manager can stay in control of their systems, of their projects. Very much like it was with the relay-based systems. They were in control, then the computer-based systems came and the big suppliers took over, and now the infrastructure managers feel lost about what they actually have. They can regain this control. Also then that the existing ecosystems in the rail domain, so we have lots of engineering firms out there that are experts in rail engineering, but those are usually not involved in the making of signaling systems from the big suppliers. They are the engineers are doing drawings of how the tracks will go when they do relay engineering and so on. Those engineering firms can now be engaged in building and maintaining open systems. This one is a bit slow. Oh, now it comes. Okay. And then also that it's possible to teach new staff how they can do this. With the end goal also that obsolete components can be replaced by new ones in a controlled way, so that this system can continue to evolve in all eternity, basically. It will never be obsolete and have to be thrown out. You can replace component by component forever with this approach. Okay. Now you are welcome to ask questions. No questions, and as I said, Trafikförvaltningen will talk about their perspective of what they need and what they want to achieve. So it's pretty well connected to what I said.
Okay, I can give some questions.
Of course.
Of course. You mentioned the different projects, I would say called projects, that are driving and trying to introduce these standards, ELUNCs, for example. Could you say something about how far we are in development of different standards here in different aspects? What are ready, what are missing, and what is great initiatives that's ongoing?
My personal, so I think every PLC vendor like Schneider and competitors, HEMA and so on, they have made a nice collection of protocols that they support. But unfortunately, it's not the same protocols. So they chose different standards, and some of them are even closed. So there are Safe Ethernet from HEMA, for example. That's a communication protocol, but it's a HEMA standard. So it would be very nice if they could all agree on one standard. It's still doable to do open signaling systems, but I think in the closest 5 years, what you would do is to create a lot of adapters. So for example, it's a natural idea to say that between stations or between systems, we want to use ULINX Rasta. And then if you use a controller that does not have native support for ULINX Rasta, but maybe SIP safety or Safe Ethernet, then you will have to create an adapter that converts. So the controller it will not be possible to replace just the controller. It will be the controller and the adapter. But if you do that, then you can start communicating with neighboring systems from different vendors. It's a bit frustrating that you need those adapters, but I guess they will be needed early, and then I hope that in 5 years or so there will be more a common standard. Maybe a bit more than 5 years. We are in a slow domain.
Another question about the ELUNCs. Robert, may I ask you that one actually? Are you? Yeah, sure. I think it's you. I think you're the expert here today. So please, ELUNCs. How far are we in the standardization?
So I think ULINX standardization has been going on for almost, I think, 8 or 9 years now, and there have been successful commercial projects that are using ULINX. So it can be definitely regarded as complete in some regard. But we have ULINX baseline 4 release 4 being published this year, and this is also, let's say, denoted a mature baseline, and all of the subsystems, so that is subsystem point, light signal, train detection system, and so on. They have a set functionality and set communication protocols. But I think, as I'm going to mention this afternoon as well, there's still room for improvement, and I'm looking forward that the methodology and the overall ambition of ULINX is going to expand and evolve in supporting the idea of open signaling and being able to interoperate between the different components and exchange them more freely as it is today.
Okay, I'll ask another question. Andreas, you got questions for sure. I know that would happen, so.
Yes, I'm curious about the interfaces. because open signaling is various interfaces very important, and how to decide what interface you should choose as an infrastructure manager. I can set a requirement. We should have this interface between our different parts in the open signaling system. But what is the best? Because I want to minimize the adapters and the rework if I change a subsystem or a part in the system. And for me, it's not clear today what standard is the best or most convenient one to choose for the market, for me as an owner, or for the system performance or maintaining of the system. That's a question I have.
I see. Yeah, that's a good question. I think we need to divide. First of all, we need to think separately of the hardware interface, so inputs and outputs. For example, if you have relays around a PLC controller, so maybe you have a switch you want to throw and it needs a relay because it needs a different current than the controller can use. Then this relay needs to be operated by the controller. And then you might already have those relays, in particular if it's a brownfield and you are replacing a relay-based system with a controller. Then you must, of course, ensure that the currents agree. So the controller might support 24 volts, but the relays you have might require 48 volts to actually pick. And then you have this problem. And there is no good, I think 24 volts seems to be the state-of-the-art standard when it comes to what those controllers support. But if you already have relays that require a different current, then you will need to replace them or fix this somehow. And I don't have a good answer what's good in general. Then we have the interfaces to surrounding systems. And it seems OPC UA is a very good protocol between the interlocking or the signaling system and the traffic management system, because OPC UA is well specified and so on. It's less sure that it's good for vital communication. And there we have Ulink's Resta as a very strong upcoming standard. As Robert said, it's an ongoing work. I think it will it will be the standard in the end for communications between stations, for example. So, and as I said before, I think it's unavoidable to have adapters, unless you want to. Well, if you want to use the built-in ones today, it's difficult if there are different vendors on different stations. So it will be less open. If you standardize on one of the built-in interfaces in PLCs, then you have an assumption that it's from a specific vendor. And you usually, then it's not open enough, in my opinion. You can choose to do that, but then it's a little bit less open. Yeah. But it's not an easy question. I mean, it's a little bit moving also. So OPC UA, there are efforts to make it vital and also cyber secure, and yeah, it might be there pretty soon.
Okay, then I asked you about Rail ML. Oh, Robert, please.
Yeah, I have one question regarding the slide that you showed with the different procurement models, where maybe we can get back to that slide. So if we have the model on the right side as our goal, essentially, where the infrastructure managers could potentially procure platform and software and system integration consulting capacities independently, then there's going to be interfaces needed between these three pillars, basically, in terms of the process on how to, let's say, deploy this software to a certain hardware platform and how to carry out system integration by looking at the combination of hardware and software. And so whose duty is it to define these, let's say, process interfaces and also the technical interfaces that are part of this? Is this something that the infrastructure managers can do, or how can we maybe enable them to define these interfaces?
Yeah, good question. First of all, I think that these models should be thought of as commercial models. This is how you organize your project from a commercial point of view. In both cases, we have the same components. So there will be a system integrator here and a system integrator here. It's just a question who buys these things. Is it bought directly by the infrastructure manager or by the system integrator? So if, for example, the infrastructure manager is happy with the application software but needs to replace the hardware because it's obsolete or old or whatever, they will probably have to engage a system integrator that will do certain checks on this. So they can procure different things. They could have a public tender saying, we want a platform that complies with the 61131 standard, and that can it will be suitable for our environment that we have, those magnetic fields, those temperatures, those this humidity, whatever. That is one tendering. And then they will need to also ask the market for system integration services. They will need to say, okay, now we have a project here where we want to replace one piece of hardware with another piece of hardware, and we need consultants that can do the necessary integration work. And maybe in this case, if it's just a replacement of an old computer with a new one, it will not be a lot of new drawings and stuff, but at least there will be an evaluation of the platform. So there will be a new safety case to see that the platform works and so on. Someone needs to do that, of course. If it's done by staff inside or outside is not, I mean, that would depend on what staff is available inside the infrastructure manager. Some such organizations are very slim and with almost no technical staff. The ones that exist are fully occupied with other things. But some are also a bit larger with engineering departments. So it varies, I would say. But the model would be that the infrastructure manager is responsible for everything, but of course they can use consultants for carrying out the tasks.
I have a make my voice. I have a question about like the interfaces to the trains. You're talking about secondary lines, and I'm guessing it's mostly like conventional signaling systems here you're aiming for. Or what do you say about maybe ETCS level 1 should be easy, but when you're going to ETCS level 2, it's much more complex with this type of open signaling, or?
So we are not targeting level 2 currently. I can't see why it would be a technical barrier. Well, of course, it's more complex, so more to be done, but there is no principle saying that it couldn't be done in the open way. But also from the commercial perspective, as I said, we are targeting the kind of market openings that exist. And when it's level 2, it's usually very attractive to the big ones. So we don't have any projects like that. So we are supporting some customers when they are doing level 2, but we are not doing open signaling for level 2. And I can't see an opportunity right now. But maybe in the future, when level 2 is more established, it will be done in an open signaling way.
Thank you.
Thank you, Jesper. Any more questions from audience or from the chat? No. Okay. Thanks. Interesting and a good start of the day. Got some discussion going. Yes, we should have. Could you get the next slide?
Yeah, it's lagging a bit.
Yeah, it's the most important part of the day. We have a break. So there will be coffee outside. There's some exhibition here in the background, and we will be back at 11. You can also show the next slide, please, Jesper. And then we will listen to Kristina Andreas from Trafikförvaltningen, Stockholm Metro. So feel free to have coffee, look at the exhibition, and we're back here again. Great chatting, great talking. We are getting ready to prepare for the next session. So please have your seat. Our next presenters are Kristina Andreas. We've been working together for many years, and I believe, if you take the next slide, please. I believe by the title that we are going to talk. Oh, we didn't have the title here, but a journey without an end. It's about how actually the system is developing all the time, and how do you keep up with that. I hope that's what we're going to talk about. I'll leave it to you, please.
Yes, we have a birthday child here today. Someone is celebrating 75 years, and it's not me.
And it's not me either.
No, it's the metro in Stockholm.
Yes.
So keep that in mind.
And it's the 1st of October of 1950. We were on the first metro train in Stockholm. And today we are here to talk about the digital transformation of our metro and our signaling systems.
And I am Kristina Löwenberg, signaling strategist, and this is Andreas Mårtensson, signaling safety manager.
Yes, and I'm also working with requirements on signaling systems. And we will speak about how small steps create a big move in a very traditional business and gives echoes outside the signaling area, because what we do in the signaling area shows mostly outside the signaling area. It's a technical organization and operational benefits you get. And we will also speak about the challenges when you're working in a public financed organization.
Yeah. A quick flash about SL, Stockholm Public Transport. We are responsible for all public transport in Stockholm. We plan, we build, and we maintain. And we have 3 metro lines, and the green line is the oldest. That's the birthday child. And we also have 100 stations to maintain, 4 tram lines and 2 light rail lines. And almost 2 million people travel with us every day. We also have transport on water, Vaxholmsbolaget. And we also have färdtjänst, taking care of our disabled people. And the best of all, Spårvägsmuseet. Go there and celebrate our birthday child.
Yes. And here you see a picture of our signaling work since the years. As you see, we have done a lot of small actions in different areas, and our rail-bound traffic signaling systems are old but reliable. They are both relay-based and computer-based, but we need more capacity, and we foresee that for the future, so we need to do something to maintain the systems. We have had a few terminated signaling contracts in the metro and so on. So it is a maintenance backlog, and we need to do something with it. We are expanding the blue line today, and we have a time frame about 2014, 2050, around there, and the lifetime extensions project on the green line too. And we see a big lack of competence and components for these old systems, both relay systems and computer-based systems. And the most urgent one is the computer-based systems. So we need a lifetime extension. We need to find a concept to extend the lifetime on the metro lines. And we have tried big bang bombs. We have tried it before, and it was not a success. It was very difficult, very hard, and we don't get a new or better signaling system. We have the same situation on our railway lines too, with old and reliable systems. But it's time to rethink, because we need to collect competence about our old systems before people retire or leave the business. And therefore, an alternative is to implement systems engineering, modularization, and make changes on existing systems slowly and controlled, piece by piece, during a couple of years. And for this, digitalization is a good tool, but it's very powerful. So you need to handle it carefully. We have used it in different shapes, in different signaling projects, as you can see on the picture. And the common part is the formal methods and the formal tools. We have used it in parallel with traditional signaling design, where you have an experienced designer, you have an experienced reviewer which tells you that this system is safe and set a sign on a drawing and so on. But we will use this in parallel. And some projects has been supported and some not.
And this is a picture of a lot of lines we have worked in. We started early in 2006 with Roslagsbanan. And then around 2015, it was time to extend the metro, and we had to do a lot of re-engineering, digitalization of drawings. We went down to the cellar and looked for very old drawings.
Yeah, for our templates. It was based on templates, the signaling system in the metro, but it was designed with ink on plastic paper or even in line.
Textile.
Textile drawings. It's very, very old, and no one wants to change them with this technique today. We need to digitalize the drawings to make it possible to do the metro extension, because no one can handle these old techniques.
But we figured out how Grandad thought about the functions in the metro.
Yes, it was reverse engineering.
Yeah, and we have continued with requirement management and also some digital twins for some parts of the signaling system, especially the ATS or traffic management system. And the interlocking and the interfaces. And of course, formal verification. Now we are looking to do the pilot and doing a guideline. And we have our project manager here today. It's Johanna from Trafikförvaltningen. So talk to her about Kymlinge. But an important project in parallel with this is MBATS. This project is a sort of innovation project, mainly in charge of our IT department, because we would like to use all these powerful tools at home, at Trafikförvaltningen, but at the moment we are struggling to build the IT infrastructure to support this.
Yes, so everyone which is thinking about to do something like this, of course, the technical part is an issue to think about, but we have solution, we have tools, we have hardware, we have principles that can be find quite easy. But you also need processes, you need new knowledge, you need skilled persons, you need an IT infrastructure because you will produce a lot of data, a lot of digital twins, digital models, and a lot of information. And you need to collect that in a very sorted way to use the benefits of it. So it's a very important part to have an organization which can support your work, your technical work. And that organization needs to be built in-house. We want to build it in-house, trafikförvaltningen.
Some pieces are missing, of course, still. It's a struggle to convince the rest of the organization. We are the individuals who believes in this, and we have the techniques, but the organization is not totally with us, but we are on a good way.
Yes, we have seen that during the last year or years that the organization is moving. When they get aware of that this is a solution, which is it's a possibility. It's an alternative to the traditional one, to go to one big supplier and buy a black box as a signaling system and get it installed and serviced during a lot of years. This is an alternative. This is a very strong alternative to do these big affairs, to take these big steps, because it's a lot of things which will be changed. And it's difficult to do big changes. So we want to do it more modular and in smaller steps and do it ourselves, owned by ourselves. Of course, we need support from the market, from different vendors with the work, but we have a vision to do it more in-house and more ourselves.
Yes. And of course, it's a partnership.
Yes, it's a
Otherwise,
very important.
it won't work.
Nope, never. You need to have long-term frame agreements with a couple of partners.
And as Jesper explained, we have these fairly small lines isolated from the national network, railway network. So and they are old, and we have different problems and lock-in problems with different vendors, and we need to change exactly all our systems in a slow and controlled way, because the traffic must run 24/7 while doing this.
Yeah, we have high expectations from the community that the traffic must run. So it's important to do it in a very controlled way with minimal interruptions in traffic. And here the digital models is a very big advantage because we can test the systems as a model or in a lab with the hardware connected first before we go out in the real system and do the changes, because they are very difficult to get back from. Have you done them? You must proceed. You could not back. But if you have tested them in a model or in a lab before, you can be more sure that you will success, or you can adjust it before you implement it in the real signaling system, before it affects the traffic. And that's a very big advantage.
Yeah. And here summarize of our challenges?
Yes, there is a lot of work to create these models from the existing system to find out the DNA of the system, because that is what you are doing. You find out the DNA and you can adopt it on your stations and the behavior of the system. But it could be difficult because the system can be developed during several years, during several projects, and it could have been changed during these years. So the principles is not exactly the same at all the places, and you need to consider which principles should be implemented, because if you do this, you have the same principles over the complete line. And also only the specified requirements will be checked by these models. If you miss anything, it will not be checked. And then you have no control.
And that's forbidden.
Yeah.
We must find all requirements.
Yes, and we have an authority to think about also.
Yeah.
Our national authority, Transportstyrelsen, will approve our systems. And they need to be convinced that the systems are safe. And that's a very important part of the work too. But here, formal methods give us a very strong tool to show that the systems are safe, because these models and these tools make the system or the safety visible. In the old times, a very experienced person told you that this system is safe, and then a sign on the drawing, and everything is okay. But they never answer the question why it's safe, because they were their own knowledge or experience who told them that this is safe.
And
it was very like an old system or an earlier used solution, so it's safe. But with these models, you can show exactly why it's safe, and you can explain it for people or organizations which not work with signaling systems daily. And that's strong.
And we have to do it that way because all these clever people have retired.
Yes.
Mm.
So you can use these to educate new people which come into the signaling business, to show them how your system is working and learn them how to work with it. And that's a very big value too, because it could also be a vendor in some kind of area, hardware or anything else. If you can show how your system work, you have a big advantage, and you can be very convinced that you see the same picture.
As an infrastructure manager or owner, you're always dependent on suppliers, but we would like to choose what supplier you are dependent on.
Yes.
And the Prover is one, of course, but it's an open supplier.
Yeah.
And we prefer that kind of partnership.
Absolutely. And I'm convinced that black box signaling system or bigger systems supplied with a vendor or a bigger supplier, it has its place in the signaling world too. But these kind of system, open signaling system solutions, also have their place in a parallel world, in other lines, less capacity need lines, or as a bridge between old systems and new, because we buying time with this. If we introduce this solution, we get more time to think about what we need in the future. We can analyze it better and still be sure that our existing systems delivering traffic and delivering service to the public. And that's a very important part too.
And our pilot in Kymlinge, the main purpose is to handle obsolescence problems.
Yes. We have a couple of relay types which are unique for us. It's difficult to get them manufactured. So we need to do something to solve that. And therefore, this pilot is very important.
By putting a computer in Kymlinge, we can take out the relays and use these relays on other stations as spare parts.
Yes, that's the point of that.
With challenges come benefits. We are very pleased that the tools help us to make all the requirements very clear and logical and easy to follow up. And especially when it comes to change management, it's traceable.
Yes, and that's very important too, because if you should know your system, you need to know your changes too.
And by putting a lot of effort in the beginning, you gain a lot in the end.
Yes, and it's often outside the signaling area. It is very expensive for the signaling part of the project to make all these models and use all these tools and do the research work, the reverse engineering work. But you get a payback later on a higher project level, because you can deliver your project accurate in time, you do less mistakes, you save redoing work, you do one thing one time and it's correct. So that leads also to that you have shorter traffic interruptions periods. You can deliver more traffic to the public, more accurate project deliveries to a lower cost. And that is very interesting, because if you should implement this kind of solution, you need to talk the language that the management levels understands. And they don't understand technique. They don't understand models. They understand money, time, and
sometimes quality.
Sometimes quality. You can use this as a quality tool too. And say, if you use these, you get high quality in your project. You be sure that you have delivered exactly what you say. And that is a very effective argument.
And time is especially important, because the altered system can do its traffical work much faster.
Yes.
In time, anyway.
Yep.
And another benefit is that you can evolve the functions over time in a much easier way. As Jesper explained, it's a hard work when we have vendor lock-ins. If you ask someone to do the alteration, the change in the system, it may take 2 years to get it done.
Yeah.
And it's also hard work to rewire a relay system.
Or they could call you up and say that our system will be obsolete. You need to change it. Okay. But my traffic is running well and I'm satisfied with the system as it is. Sorry, you need to replace it because our knowledge of the system or our components are obsolete, so we need to change it. And I have no choice. It's just to jump on the train. And that is not always the best way to go.
Now, some keys to success, and they all start on P. Why? I don't know.
No, I don't know. I started with this, and I find that patience is very important because things take time. things take time. It takes time. We have worked with this since 2006, even before I started working at a trafikförvaltning in Norrland. So you need a lot of patience with this. Take it in small steps. Take a step back then and see what I have done. Are that good enough, or should we try again? And you should also establish partnerships with stable partners on long-term agreements. So you can have stable relationships and a very open working discussions and so on. And you also need to have the right people in place. You need to find the most experienced or skilled people to do this, both for the old systems and for the new system, for the new concept. You need a lot of skill and engagement. Otherwise, it will be very difficult. You also need the processes in place, and that's an MBATS part.
Yes.
The processes, the infrastructure, and the establishment of the processes in your company. And you need a promoter, maybe an ambassador.
Yeah.
You need a person which think of these every time.
And who is dedicated.
Yes, and also engage and can argue for the solution with good arguments during a long time, because you will meet struggle. You will meet people who say that this is not possible. You cannot do this. It's not safe. You can meet them on different level in your own organization or external. You can meet them at the authorization area too.
Yes, absolutely.
So you need to convince them that this is safe. This is a good idea. Just do it in the right way, in the right steps. So an ambassador is recommendable to have in this part.
And the next chapter is incredible, exciting. And you are part of this. You're part of what's happening just now. And we are very pleased after we started to talk about this 10 years ago. I started at Trafikförvaltning in 2015.
Yes.
To work with the metro, and it's a long way. It's a long journey, and we talked about it's never ending. But that's the case. It's not frightening.
Yeah, no, it's not frightening, and it not means that a never end is a negative thing. It could be a positive thing, because you could develop these in many ways, in many steps, in many areas too.
And we start with in a small scale now at Kymlinge, and our ambition is to expand this to a larger scale. And our IT department is very, very supportive. They support us very well, because they see that they can expand their support to other areas in our company.
Yes, and the overall idea with this is to be a stronger infrastructure manager, because we want to know what we want. We want to know what way we should go in the future, and this is a method to achieve that. To be a better purchaser, to be a clearer requirement, get the market clear requirement.
A better dialogue.
Yeah. A more common understanding of our needs. That's a larger goal of these. And the next chapter will we maybe speak about on the next SDA?
Yeah, we hope to get invited.
Maybe you could get an update then.
Now, any questions or feedback to us? Have we missed to think about anything?
Yes, so we have a question from an online attendee. So his question is, what will make the in-house approach better than the external supplier approach solution?
We gain knowledge ourselves about our systems, and we are then able to perform a better dialogue with the market when we prepare for different partnerships.
Yes, and an external bought system is a little bit stiff too. It's a black box with their functions and safety and so on, and it's not possible to change. It's very difficult to change, but our expectations are changing often. So we need to change the system too, not regarding safety, of course, but functions need to be implemented or removed or changed during the time. And that's very difficult if you have an external signaling system supplier. It's more easy if you own the requirements or behavior of the system yourselves. Then you can ask a supplier to support you in the change, but you always know what you need.
Thank you. Any more questions? I think I could promise you that you're invited to next SDA.
Okay.
So thanks a lot for Andreas and Kristina for sharing your journey. And like I say, we're not done yet. I have a few more ideas, so let's go.
Okay.
Next presenter, where do you have? Yeah, good. Like. Next presenter, we have Fredrik Bergström from Cactus Rail. He's the CEO of Cactus Rail, and I do believe he will talk about development work and new installation of new traffic management system in Stockholm Metro, and the experience we've done together in that journey to work on this. It looks correct, Fredrik. No, we don't. Jonas, please, some sound.
Hello, hello. Yes. Ah, just det. Right, hello. It's very nice to be in an audience with a lot of physical people in a sort of user community setting. I missed that. We had that for a lot of years, but COVID and other stuff changed that. Yes, we are a small company in Gothenburg, and we develop traffic management systems. We have done that for very many years, and Trafikförvaltningen is our largest customer. And the presentation will be focused on the traffic management, the integration with different kinds of systems, and also with integration with interlockings, as we do not supply interlockings by ourselves, but we integrate with them. And we're also working with Prover in the Stockholm Metro project. So that's the line. And as Jesper said, we believe in this reuse methodology, that you shouldn't change everything. You should keep what is sound and make that reusable for the future and make it to be life extended. And that's why we also have this gradual process for modernization. And it's been very successful. So what we're working on the most is this high-intensive lines with commuters in and out of cities. And we are controlling the regional lines in Stockholm. And we are currently working with the red and blue line. So we will actually transport a lot of people in a couple of years. And it's more than the complete national grid, actually. So it's very important systems that we are very proud of being responsible for in delivering. And just a short recap on the TMS. It's a central system located in a dispatcher's office where you can visualize the complete line, and the train is moving along automatically according to the time schedule, and the dispatchers can enter and do adjustments according to what happens in the reality. And there are lots of different views. Here's a typical environment from a dispatcher's office. I believe this is Roslagsbanan. So that's on us. And working with rail is, of course, very encouraging. It's a sustainable, important business. And when it works, it's very efficient, it's sustainable, it's a marvelous way of transportation, I would say. But somehow we have a lot of real-world limitations, lots of different technologies that is old, that is highly diverse. It could be difficult to interconnect them. So it's a tough reality. It's also being delivered under a lot of years. And what we need, I think, I agree with open signaling. We need to modularize things to be able to reuse and do this in smaller steps. And here I have lent a picture from the website and positioned us in the system integrator, because that's where we are. So we take a turnkey delivery of everything, software, servers, hardware, PLCs, commissioning, consultants, education, everything. So here in this project, we are working with a hardware platform supplier, also application software, and of course we have our own independent ISA, as well as the customer have their own. Yes. Sorry. So this is the theme of this session: to do it faster, to do it leaner, and to do it safer. And I think that's the keywords in reusing. So what we do here in the metro is that we are proving a lot of customer value very, very early. We received the order in November 24, and we did pilots in June 25. So it's very fast in showcasing value of principles. And also you could keep the existing infrastructure, and then you could modernize successively. Of course, here it's very important to do it safe, and also here we're working with a prover and a digital twin to be able to simulate the behavior in our offices before we do the rollout. It's very important. And we also have a fallback so we can switch in between. So we can move fast just by putting the system on top, and we also have a safe way of migrating between new and old. Of course, we will do this very fast. So changing everything could take 10 years. Doing like our approach could take 3 years, keeping the existing infrastructure. And also, like Andreas said, it's a lot of all the DNA in interfaces that we need to dig into. And when we are delivering this project, you have a new understanding of all the interfaces for communicating with the trains, commuting with the passenger information. So you get very fast understanding, and the customer also get knowledge of the behavior. And in this project, we keep the vital relays, and we change the non-vital relays. And it's relay interlockings. So we are mixing new into the old. And it's also a kind of project that we really like to do these secondary lines, as the word was, and to understand the old technology and integrate it into this old stuff. It could, whatever it is, relays, interlockings, PLCs. So we are communicating with, lots of different kinds of interlockings from different vendors. Shadow running, I guess you know, we listen before we roll it out. And also we test it in lab before. So we can do it a fast implementation, cost effective, and we can do it at the same time in a safe and sound manner. Yeah, it was a citation from the tender that showed these principles. That was appreciated. And I will get into the case. Try not to fall off this stage. But here you see an old control center. It's from an old picture from the 60s. And it's, you see the line there. And for these red and blue, it's 64 stations. And we are reusing all the interlockings. We are digitalizing the non-vital relays. And we are placing redundant PLCs on every station. So it's a complete modernization project. And it's a blue line, it's a red line, and it's also being, the red line is being extended. And I believe parts of the green line will also go into our system in the future by natural changes, nothing else. This is one way of looking at levels in the system. There are lots of levels, but let's stick with this one for a while at least. And we have the number 2, which is the operations, eller drift. There is where we have our TMS system, where we control, where we lay the traffic automatically, and then we have integration platforms for communicating with interlockings. Could be PLC, computer-based relay, whatever. And then you have all the just as important top systems to keep the communication with the customers, with the operator, and so on. We will just dive into these 3 here. So I have a first picture. Yeah, the left part should illustrate today's scenario that it could be. It's finding specification, finding protocols could be a challenge, and we need to digitalize them, modernize them, and to create very clear and modern paths to interact with the different kinds of systems. And I would say this part is almost or as challenging as the TMS part. So the developers are working like, let's say 50% with this and 50% with the TMS. A lot of sorting out. But it will be excellent. It will be very good. And you will have modern specifications and so on. And number two, then, if we move into the TMS, this is not from the from Stockholm, but that's an illustration. You have an old control table environment where you have the track layouts, and we will move this into a modern way. And you can see some work in progress pictures on the screen there in our stand. And this is where Prover helps us with a very important part, is to have this non-vital relays. And Trafikförvaltningen is also modernizing the schematics. That could be on textile. I haven't heard that. I worked for a long time as well, but I just seen this plastic with ink. But textile drawings is, yeah, it's a good, interesting to know. Anyhow, so these electrical schematics are transferred into logics that we enter into the redundant PLC setup with the instant switching, and they are close to the relay interlockings. So we have redundancy, high availability, very low. And the vital relays is being kept. So a picture from this 1, 2, 3. You have the operational systems and perhaps more IT systems. It's OT and IT. We integrate with them as they are separate modules. We have an integration platform that is open, where we have loosely coupled infrastructure, so the customer could connect different kinds of IT systems into the integration platform. We have the TMS, which is our core product, and Prover is doing the conversion, digital twin simulation, also in the maintenance phase over the years when we are doing transformations and modernizations in the relay logics. And then we have the same platform actually to communicate with whatever you have downwards. And this creates then a very fast implementation, cost effective and safe, I would say. And then the customer have the command, they have the knowledge, they know their installation very fast. And then they can have a little green arrow there. They can change the interlockings in the time and place where there is money or principles or, yeah, the way they see fit and timing. So this is modularized, I would say. Yes. Here are some values that we have come up with. Of course, you can look at it, but it's basically is going into a modernized world like a time machine. In 2 or 3 years, you have a completely modernized setup. You have digitalized control over the objects. You could have condition-based monitoring. You can have better information on where the trains are. Yeah. You spare free parts, as you said, some as well. Okay. So by this way, we're working with all 4 of these segments. We see them natural. We could move in any sector, but nowadays we are the system integrator that is facing the turnkey delivery, sort of. But it's modularized offering, and I think that is the way to go as well. Perhaps someone is wondering why giraffes. It's and I was thinking of like in how should we do this presentation? And of course, giraffes, they work naturally in the ecosystems. They have a high reach. They see strategies clearer. They have a big heart. Of course, you have to have, as a small supplier, we are very close to the customers. They are very important to us, and we have an adaptiveness in the ecosystem, which is very natural for success. And actually got in EU links as well in this. Yeah, and I think that this combination of the suppliers in this project, we have a very strong case in doing this in other places. And you should see these relay lines with non-vital logic. It's thousands of relays. And of course, it's a challenge to do that safe. So once again, Prover, it's well done so far, and it's a very important job. And I'm convinced that others would like this as well. And there we end.
Thanks a lot, Fredrik. I open up for questions from the audience to Fredrik. Yes, it's about the giraffe, I guess. No.
I have giraffe candy as well in the stand.
So the question is, do formal methods play an important role in this project and now? And how, sorry?
Yes, it's a very important part in digitalizing these electrical schematics and having they transferred safely into PLC logic. So it's absolutely very important.
This is not a question about the giraffe, but about the signs that always stood by the giraffe. So yes. There was the pilot and the lab.
Yeah.
And those make sense to me. But I'm curious about the corridor sign.
Yes.
Could you expand a bit on what that means?
Yeah, I can. Perhaps the image generator doesn't always do exactly what I tell it. But it's the corridor is, as we also do, working with ERTMS, and then it's a corridor rollout. So, but it could just as well be a station or a section or a line. It would be a better word. So I understand that corridor seems a bit off. It's a keen eye there. So see it as a successive installation.
I have two questions. First, what does CCS stand for?
Cactus Communication Server. It's our own integration platform.
All right. And then, of course, you answered why the giraffe, but why Cactus?
Yes, Cactus, it was actually a naming competition way back. And it's a sustainable plant who flourishes in harsh environments, protects the water, protects what's good. And it was much nicer to have like a name that stand out that is international rather than 3-letter something, automation or numbers or something. So it's a nice marketing name, I would say.
And maybe that was an Easter egg, but I'll go for it. So have you, is the Ulinks interfaces implemented for the Metro?
No.
TMS? Okay.
No. We have not implemented the Ulinks anywhere yet. And we also we did a communication platform for the Swedish interlockings, and Ulinks is not implemented there. I guess it's coming.
Okay.
It looks like you had a follow-up question. Maybe later on. Okay. But we will do it. It's our I would say, a competitive edge is to convert or doing these adapters to communicate with whatever interlocking the customer have. Like in this Roslagsbanan, Saltsjöbanan, Lidingöbanan, it's various kinds of interlockings, different types and age, and it should all look the same on top.
Great. Any more questions? No, I think we say thank you to Fredrik.
Thank you. Thank you.
And I love the giraffe thing with the big heart and the overview. That's actually you, Fredrik. So please, thanks a lot. Next speaker, we have Juan Manuel from Schneider. And he will talk about how to work in an open signaling way with the hardware platform. Welcome. Oops.
Is it working? Can you hear me? Okay, perfect. So let's check that it's working. Okay, it's working. Okay, first of all, thank you very much for giving me the opportunity to introduce Schneider Electric. Probably some of you will know Schneider, but for the ones that are not knowledgeable in the company, I will give you a short introduction. It's very rare, it's very strange, because when I am in front of my customers, normally the first words that I say, well, not the first word, but one of the first words is that we are not a signaling company, in order to clarify that Schneider Electric is not participating in the signaling world. And I'm now in front of you to say probably the opposite. But you are not a signaling company, but we try to work into the signaling environment. This is something interesting. The title of the presentation is From Industry to Railways, How Schneider Electric Can Enable Safe and Open Signaling. So because I think it's the way from industry to railways. So we are an industrial company, so we work in safety in industrial environment, and we think that we can provide some insights and some, let's say, experience in order to leverage this experience that is now working in the industrial environment into the railways environment. So presentation that is very short, as you can imagine, has 4 different topics. The first one is the very short introduction of the company in order for the people that is not knowledgeable in the company, and what we are doing today in the rail environment, because we are a rail player, but not in the signaling world. Second one is the safety cases, safety use cases that we normally deploy in other contexts that I think is interesting to know, is how to reuse the experience in other industries. And there are a lot of industries that are interested in safety, not only railways. And the third one is how we plan to make this, let's say, entering into the market. So what is the offer that we can provide to the market in order to start, finishing with EULINX, how this fits into the EULINX initiative that is probably the end of the presentation. So I think this is the journey that we are going to follow during this presentation. So when I have to introduce the company to my friends, to my colleagues, even in presentation like this, I normally start saying that Schneider Electric was founded 200 years ago. So it's a company that was founded even before the Industrial Revolution. So even before electricity was a reality. So as you can imagine, the first steps of Schneider were not related to the electricity. So nowadays it's a combination that is very strange, because it's difficult to discuss with somebody that has 200 years worth of experience about the state of the art. This sometimes is contradictory, but this combination of experience, I mean tradition, because it's a traditional company, with something that is in the edge of the development, it's something that sometimes is compatible. And you will see that when I explain later about the product's history, I think it's something that is totally compatible. Regarding the company, 38 billion revenues, which probably for me is a lot, of course. But if you compare, for instance, with other companies, because comparison is normally the success of this information, Apple is 400 billion. So we are approximately 1/10 of Apple. When you compare to Apple and you are 1/10, you are very big. This is something that is clear. 153,000 people around the world. So this globality, I think, is something that is very, very important. Presence in all the world, as you can see. Our business is more oriented to Western Europe and North America, but you see East Asia Pacific is one emerging market that I suppose, and I'm sure that in the future is going to be probably the biggest in this map in the presentation after 10 years. And then two main businesses, which is industrial automation and energy management. This is the focus of the company. And also one equation. This equation is very important. Digital plus electric equals sustainability. This is the equation that is driving the strategy today of Schneider Electric. Digital, I mean, using software, mainly in software. Electric, because electricity is the driver of everything and is very related to decarbonization. And the sum of the two concepts is sustainable, which is probably the driver of most of the investments that happen today. What is the present today of Schneider? These are the four pillars. This is the typical presentation I do normally in front of my customer. As you see, signaling is not here. Signaling is not about safety, it is. This is important. First one is reliable electrification. So we have a solution for the supply of electrical energy to the different consumers that there are in a rail network. Main one, the train, 75% of the consumption is the train, and 24% for the rest of the consumers. By the way, the interlocks is one of these consumers. Second one is safety and comfort. So we are working also in passenger station where comfort is very important, and also working in tunnels. Tunnels is the place in which, for instance, safety is currently present in the rail market. Digitization also, because you know data is critical today. So the management of the data is critical, and control center is one of the places in which the data is very, very important, because aggregating all the information of the field equipment. So we have solutions also for control center, not for traffic control center, but just for the rest of the potential systems. And finally, decarbonization. I mentioned that decarbonization is a very important driver today. I will have solution for the specific case of the decarbonization, such as, for instance, deployment of microgrids. This is a special grid that you can deploy in one facility, and also solution for energy efficiency, mainly focused in the building area. So these are the different facilities in which we are present. We are present in the power substations. It's the traditional scope of Schneider Electric. That is powering the train. We are present in a transformer station that is powering the rest of the consumers that are in the rail lines, such as, for instance, in this case, the interlocks. We are providing also secure power for the interlocks, because power is also very important for them. In passenger station, we are present also in tunnels, in depots, where we can provide the electrical device, the electrical supply, and also we can provide the management application for the facilities. And finally, present in the control center, not in the traffic control center facility, but as you can see, we are present with references in the case of the SCADA solution, the management solution for the areas of power, passenger station, tunnel, and depot and workshops. And finally, even in data centers, because we have a very good portfolio for data centers, only for your information. So why Schneider? Why Schneider could be a very interesting player in the case of signaling? The reason is because we are present in safety. I mentioned before the tunnels, but tunnels is in transportation, but there are other areas in the company in where safety is critical. And the reason is because safety is very heterogeneous. We normally think of safety regarding transportation with the safety regulation that we know perfectly, but there are other areas that are also important in safety. The first one, for instance, is in machinery, which is machinery for safety for machinery. So we have projects in which what is important is to avoid people to be in some places, which is very similar to avoid trains to be at the same time in the same point. So which is the definition of accident. So there are specific regulations for it. So this normally there is a derivation of the base regulation, but at the end, specificities for the machine. We are also present, for instance, in process safety. You have a process, normally industrial process, in which you want having some income, you want to produce some output. And in the process, there are some, let's say, dangerous parts. So this is very typical in this case, the monitoring of variables in a safety way to compare to some thresholds, and when something is outside the boundaries that are normal, then in this case, stopping the process because something is going to happen. So this is more or less approximately is equal or similar to the concept of safety that we have in railways. And also in railways, I have mentioned that they are also present, but I think it's the same slide. So finally, we are present in this area today. So we have a good references where safety is critical, and that is the reason we have a safety controller in the areas of mineral, metals, and mining for the processes that normally is process controlling We are also present in oil and gas and chemical building, which is very, very oriented to the process. So the process normally has things that are heating, that are burning. And of course, as you can imagine, this process is dangerous and you have to control. We have also present in the case of consumer packaged goods, so bottles and this kind of management in which machinery is critical today. And also present today in transportation. Today, I'm not saying about in signaling because we are present in the market of the tunnel ventilation. You know, a tunnel is a confined environment when there is a train or there are people or there is a road and it's a dangerous place because a fire inside the tunnel is normally a critical situation, and fire management is part of this. And finally, we are also present in, there are some systems in order to trip the electrical system in a safe way. We are also present there. And finally, we are also present in airports. Airports, the manage of the luggage, the baggage management system is also considered a critical one, and we are present there. So we are present in the safety world, but not in the signaling world today. This is one example for your reference about the simple architecture for a tunnel management system. As you see, there are several PLCs, because in the context of industrial solution, it is called PLC, Programmable Logic Controller. But it's red. Why it's red is because it's a safety PLC. So it's a safety that has been designed, especially for the implementation of a safety process, according to safety regulations and of course according to a procedure that is very clearly specified in the regulations. So this is the type of equipment that we want to migrate from the industrial process to the signaling world. And this is the one that we are working, and by the way, is in several of the stands of the room. You can see that there are redundancies, equipment that are placed twice at the same, normally in different places in order to have one geographical redundancy, and then distribution of different PLCs in order to acquire information from the field equipment. This is the principles of the control. For the management of the different subsystems that are in the center, such as, for instance, pumps, power, CCTV, access door, lighting, so ventilation, which is probably the most important. And then in this way, you are able to manage the process of the management of the tunnel. And when in the tunnel there is a signal that is indicating that there is a fire in some place, you can activate immediately the mitigation plan. That is the base of this system. Sorry. So our solutions are normally structured in 3 different levels. I'm not going to go into details of each. The lower level is the connection to the field equipment. The second level is the operational level, when normally the responsibility of the operational plan is implemented. And the upper level is the one for analysis. Analysis, data analytics, and all the different services that are not related to the real-time environment, which is in the middle. So this is our plan. So our plan is to use the controller that is in the middle, that is managing the process, into a new process that is really different than the one that was used before, but it's something that we think is totally reusable, and we can leverage also the experience that we have. Certification regulation are different, but we are having, so the PLC is certified SIL 4 in signaling, so I'm not talking about process control, I'm talking about signaling certification, and nowadays is usable for that context. But of course, before the Open Signal initiative, we were not very successful, because to try to use this in the context of a traditional signaling company is very difficult. It's very difficult because they have his own development, they control this development, and it is very difficult in this case to enter in the market with this equipment. But today the situation has changed. So the market is more open. We are looking for something that is more interchangeable, which is probably the basis of this. In industry, it's very common the use of one PLC, others, so it's more easy to exchange this type of equipment. In fact, in energy, we were in the same situation 15 years ago. In energy for traction, for rail traction. In the traction substation 15 years ago was in a nightmare. A lot of equipment from different manufacturers, a lot of protocols, but today there is a standard, which is the IEC 61850, which is managing the interoperability between the different components inside the traction substation, which is exactly the same what is happening in the case of signaling. So it's one example of a success history of something similar, but it can be reusable. Unfortunately, fortunately, the substation, there is no safety. So in this context, it's a little bit more complex than in the context of the safety of the traction substation, but I think the example is good enough. When I mention combination of tradition and state-of-the-art is because of this. The initial version of the PLC was in 1978. In fact, was the origin of the PLC. So I am also proud not only to be in a company that is 200 years old, it's because I am proud that nowadays Modicon, that was the inventor of the PLC, is now in Schneider Electric. Modbus was invented also by Modicon, that is now in Schneider Electric. So we are part of the history of the evolution of the PLC. That finished there in the final equipment, which is the Modicon M580, that is the one that is in the stand. So this is the equipment that we plan to use in the context of the new context of the signaling. Very briefly, because I think this is not the purpose of this presentation, and also because there are people that are more knowledgeable than me in the case of the features, but these are the main features of the controller. So features regarding scalability and resiliency with redundancies is part of the capabilities of the equipment. Safety communication is part of the features of the equipment. You see that, for instance, CIP protocol is implemented. Rasta is not in the list, but is going to be in the future. So this is part of the work that is deployed today. Oriented to the data, this is fundamental. So I mean, safety is important. That's the core of the solution. But you need to make available information for the rest of stakeholders into the traffic control system, because at the end, it's going to happen, the movement of the data. So once you have secured the safety, then in this case, there are a lot of data to distribute. So this is also important in the composition of the PLC. Certification, you see that there are certification in aspects that are railway oriented, for instance, for railway, but the rest are not oriented to transportation at all. But the system was designed also for that. Combination of safety and non-safety. Sometimes you have one position in which safety is important, but there are other aspects that are non-safety related because it's not a safety function what you want to be implemented. It is possible to combine using the same equipment, both safety and non-safty functions. And finally, the engineering tool. So this is a combination of software plus hardware. So in this case, the software has to be also something very important and relevant. And I think we have a very good tool in order to configure the device. And my last, let's say, technical slide is regarding cybersecurity. I think cybersecurity is an aspect that is security. It's another type of security that today is very, very important. Perhaps not as important as safety, but I think the second topic to discuss is cybersecurity today, because as I mentioned, the availability of the equipment in order to spread data in other contexts is something that creates some issues that we have to control. These are the properties of cybersecurity that the system is having today. Regarding the hardware, I can mention, for instance, the TPM, the Trusted Platform Module, very famous today, because if you don't have it, you don't have Windows 11. The other possibility is the capability for authentication is another feature that is very important in the equipment. Hardening, not to open anything in order to access to the equipment if it is not strictly necessary. The operating modes in order to certification. There are certifications also in safety, and so not only in cybersecurity, not only in safety. Certification is in cybersecurity is also a very important topic to consider when you are choosing a platform. And also communications. As you see, Strasta is not there, but it will be. And finally, the trustability, that is very important, because in cybersecurity, it's important to avoid the attack. This is very important, but it's more important to be aware that you have been attacked. So this capability for traceability is critical in the context of the cybersecurity. So what is our plan? What we plan to do with this equipment that I have described in the previous slide? Well, we plan to be inserted here into the ULINX initiative, because we think that can fit perfectly as interface in one point of the configuration. Today, and probably you know this drawing because it's very famous for the people that is involved in the initiative. Today, our plan is to be focused in the cross level, in the level crossing. Sorry, but of course that is exportable to other points in the configuration, because at the end, once we have confirmed that the system is totally usable in the context of one of the modules in terms of the input, the output, the capability to exchange information using the protocol, then the use in other part of the configuration is more or less immediate. So this is the current state that we have today. This is the way in which you can check the configuration that we have in the stand. And well, that's all from my side. Thank you very much for giving me the opportunity. And I hope that the initiative is as successful as the one that was for the traction substation 15 years ago. Thank you very much. Questions?
Okay, we have questions here. from chat.
A question from an online attendee. He's asking, is Schneider's ambition to become a signaling supplier?
Depend what define a signaling supplier. So we don't plan to be a system integrator for signaling supplier. What we can be in the model that we saw in the previous presentation is to be a supplier for the platform, for the equipment. That is our ambition today. Not to be, let's say, a system integrator that is going to be in front of the customer selling interlocks, selling traffic control systems, selling these kind of applications. But we want to use this module, which is the M580, in the context of signaling, but not developing the application that is behind. That is our ambition. I don't want to create confusion because this is important also.
Another question, is it already implemented in level crossing?
No, it's in a study. So we are analyzing the feasibility of it. We are developing the RASTA protocol, and we are starting the, let's say, laboratory internal testing of the solution, but it's not implemented in any real solution, but I hope it will be in the future. Comments, suggestions? This is bidirectional.
Other questions? Okay, I shoot my questions then. You have experience from other industries as well, and now you also work with railway and the certification here and the work ongoing. And I've been quite long in the railway industry. In the beginning of my life, I worked with many different areas, but which other domain should we as a railway companies look at to be better in terms of processes and standardization and so? So which domain here is actually doing very, very good work of driving standardization?
When you say domain, what do you mean?
I mean, is it electric, is it avionics, is it automotive? All the different standards you apply to, they are from different domains.
I think all of them are applicable. So I put the example of electrical because in electrical, we were in the same situation. I remember the conversations and the problem. You arrive to a traction substation and you see a nightmare of PLCs coming normally from one provider, but you go to the other substation, there is another PLC coming from another provider, and what is applicable in one substation was not applicable in the other substation. And also the nightmare of the extensions. I want to extend the system, so I want to add one signal in the system. Was a nightmare in order to add one signal. And this is coming from one technology provider like me. So sometimes it's something that favored me, but that was not maintainable. And in that case, what is interesting is that the initiative was taken by the utilities. The origin of the change was not even in the rail market. Rail market was using what was done, but the utilities, I mean, the utility companies, the electrical companies, take the lead in order to make this change. And they said this has to stop. This is not manageable anymore, and we need one standard in order to organize this and to assure that the equipment that are coming from one company is interoperable with other and exchangeable with other. And that was the main aim of the standard. The standard is managing everything. So it's managing the definition of the functions that are inside the traction substation, similar to ULINX, is managing interfaces, the protocols that are used inside the substation. So how do you define a substation? What are the model of the substation, and how do you have to do it? The typical files, the format of the files that you need to use. So today, what our customer, that is normally the railway administrator, is giving to us is the single line diagram in a digital way and the description of the substation they want to do. And this is sent to the people that is working, for instance, in the control and protection system, to the people that is working into the physical configuration of the substation. So they have a digital model that they can share with the different providers in order to get what they want. In the past, that was not possible at all. So imagine all the drawings in paper, the people using the totally proprietary protocols, totally proprietary equipments. So the change was dramatic. And today is much, much easier. And when you go to one substation, you see equipments. When you go to other substations, you see probably different equipments from different providers, because we don't want to change the situation from one quasi-monopoly to another with different people quasi-monopoly. No, this is not the ambition. So the substation has different providers, but it's totally clear what is the function of the equipment because it has been established in the standard. And in the different position, the functionalities are totally standardized. So it's a situation that is, I think, could be the objective of what happened in the signaling world.
Yeah, good, thanks. I'm looking forward to that. That took 15 years.
15 years ago, yes.
Yeah, okay. So how fast will you do it in railway? Not 15, I can promise you. But another question, what was the key success factor for this to happen? Who was the driver for this? Sort of.
For me, it's clear. The driver was the one who is going to receive the benefits. Yeah. I mean, the end user is the one who pushed a lot in the case of the electrical change, and without the support of the end user, it's difficult to because he's the one who received the benefits, who has to understand what are the benefits first of all, and we need to know how to explain it, and then to understand exactly that the new situation is much better than the previous one, which is what happened in the electrical world. If they want to learn from the experiences, I think utilities could be a good point in another market. What was the transition from the previous situation to the new situation, and what I'm saying, to confirm what I am saying in my words, because I'm part of the game, and what interest part of the game I mean. But perhaps it's a good way to get knowledge and to get experiences coming from other users in other markets, such as the electrical ones, in which they had the same problem and they have made the transition to the new one. Utilities nowadays is totally different than the situation that was 20 years ago, and then 15 years they start discussing about how to improve.
Good, thanks. And I know you're also part of the Universal Automation Organization. Could you say some word about that? Because I think that's a good initiative, and what's happening with that?
Yes, well, in the world of the automatization, we have also several possibilities that are usable in the context of process automation, that are the automatization of processes, but in which software is taking a very important role. So you know what is software-defined something is what we are trying to apply into the automatization world. So the base are normally in systems that are very simple in configuration. This coming from the communication world, by the way. And then you use the software in order to configure the behavior of the system. So the system is flexible from the hardware point of view, but is configurable from the software point of view. This is a change. This is a change in the mindset, because normally the systems are normally very less configurable at the local places and less important the software. But today we are trying to change that in order to make a situation that is very similar to the one that is very used today, for instance, in the telecommunication configuration, in which the configuration is very flexible at the endpoint, and then the configuration also, so how the system is behaving is more software oriented.
Thank you.
Welcome.
We have more questions over here. Good.
Yes, another question is the platform certified for SIL 4 signaling systems?
Yes, it is. It is. It is now certified. It's usable in the context of something that is the requirement is SIL 4 according to the railways regulation. Yeah, and I never remember the number. Sorry.
Another question from our audience? Comments? Oh.
We're on time.
Yeah, well on time, for sure, for sure. Thanks a lot, Juan Manuel. It's interesting to listen and get insight.
Welcome.
So now it's the next session, or next session is actually lunch break. So, and I know for you online, we will be back at 2 o'clock with a presentation from Henrik Roslund from TUV SUD to talk about ERTMS data and verification in Switzerland. And also we will have a speaker from Germany, Robert Schmid, to talk about ELynx. So that's a good continuation of what Sherman talked about. Before that, we in here will have lunch together. The lunch will open at 1 o'clock. But so you have free time here, but I think we need to walk somewhere. Up, we need to walk. So how do you do that? Is it floor 6? Okay. Yeah. And we have tables from 1 o'clock. Yes, good. Please have a short talk with each other, have a more look at the exhibition. Yeah, have some spare time, and then we meet each other. Or yeah, at floor 6 at 1 o'clock. And the elevators is that direction. Yeah, okay, thanks. Good. Thanks a lot. So after lunch break, the tough speech to do actually, but I know Henrik will keep you awake because he has something interesting to tell you. I think if I can get my CEO here to join and enter room, keep times. No, we leave him out. Next speaker up is Henrik Roslund from TUV SUD, Swedish guy living in Switzerland for many years and been working with ERTMS at CS and also a lot with handling SPB's data and digitalization. Please, Henrik. Sorry. No, it's not working. No. Do you hear me?
Hallå? Yeah. Whoa. Okej, vi startar. Grüezi miteinander. This photo is not from my living room. It's not my office window either. But I will speak about Switzerland. And here are two photos of my co-authors, my colleagues, that without them, I wouldn't be standing here. Christoph Biri from SPB and Robert Ekbach from M2C Expert Control. And then we have some guys too, Peter Ruch, Omar Selikbos, Stephen Brown. Without them, we wouldn't have come so long or far we have done. So, as Mats said, I'm Henrik Roslund, living in Switzerland. And I'm a Lego fan and I love outdoors. And I want to show this picture as well because it's important to take a break when you're stuck. Because when you're outside doing what you love, then you get the new ideas, the solutions. And often I stopped when I'm riding and then I had to write something on my phone because when I go back, I've forgotten it. So, yes. Quick facts, SBB, Swiss Federal Railways, Schweizerische Bundesbahn. Over 3,000 kilometers of track, 5,000 interlocking, everything is ETS compatible. And level 2, in commercial operations, we have 8 RBCs today, coming more, I will show you. And at least 4 RBC interfaces. Almost 12,000 trains a day, where 8,000 passenger trains. And then short about TUV SUD, we have 4 locations. We have 2 labs where they are getting paid to blow up stuff. And we are also in Switzerland in the main business areas of TUV SUD. And let's go back to the railway, the fun part. Here's the map of Switzerland. With blue is the current ERTMS lines. We have the big one, the Gotthard. Here's the Gotthard Basis Tunnel. And then we have the Lötschberg from the BLS. And we have along Lac Le Mans. And the big one here, it's 20 years old with ERTMS level 2. It's on the main line, Zurich-Bern. And I started my journey with ERTMS at the pilot line in the year 2000, and the next project up is doing it again. And in Switzerland, we have the Federal Office of Transportation, or BAV in German. They published 2023, now it's 2 years ago, a new strategy of ERTMS in Switzerland. And it's only for the standard gauge network. In Switzerland, we have 3 or 4 gauges. And it's for maintenance and expansion of cab signaling, or in Swiss German, FSS, Führerstandsignalisierung. And optical signaling, the level 1, it's in exceptional cases, very exceptional cases. And the Ministry Transport, they control and coordinates the progress according to the vision. The infrastructure owner and industry ensures achievement of the strategy together. And all these measures are in 4 categories, and it's totally 36 measures. And in 2060, it should look like this. Everywhere, ERTMS level 2. When we in team saw this for the first time, the first question, when we will retire? So we said, yeah, our kids and grandkids will have to do. So it's a very, very, I would say in Swiss we say sportlich achievement. How to do it, not the way we do it today. No way. So I will talk a little about one of the messages of the Maßnahmen in German, I11. The planning, the data prep and testing must be digitalized more than today. And big word, a political word, I hate it. But we have to simplify everything. But still, the train traffic shall be safe. It must go faster. It takes too long time. And we must industrialize it. That's what we are doing, trying to do. So now I will go in a little to the data. What does it look today? So I will go for here some slides. It's Christoph Bier's slides. I will be on thin ice. And one of these orbits is, for instance, the one that only controls the Gotthard basis tunnel, the two tunnel rows, not the outside, a little outside. It's the whole planning data is 100,000 attributes to plan. So it's like over 100 switches, a lot of main signals, 400 balise groups, quite a lot. And it's 50-60 kilometers long. And the hieroglyphics, what you see here, is defined by the syntactical rules, it's 800. The planning rules, for instance, distance between signals, balises, and points, 260. And today, planning verification takes about 300 hours. But it comes more and more complex, the same thing. And unfortunately, we have lots of cases, it takes 800 hours. That's a lot of hours. And it's not funny hours. And it's mostly, as you see here, this is one of the ESA concept tables. That's the planning data. And red means it's not according to specifications. Green means it's according to specifications. And gray is don't test it. So easy, red stop, green go. And it has consequences. I mean, there's a lot of data and it's a few people. I don't want to throw anyone under the bus. There are excellent engineers at doing it, but the workload is huge. And of course, as in many branches, when a fire starts in one corner, it's the same people that goes and try to kill it, and then it starts another one on another day. Yeah. But I mean, the consequences is cost, more work, because the other projects that are in line will be later and later and later. And it's just, it's confusing frustration everywhere. It's complex, extensive, expensive, unpredictable. So now I will show you a little about what we have learned about the red parts there. Data correctness. We've tried to do it formal, but we've seen we cannot do it with bad data. We have to clean the data and also communicate why the data is not good. So I will take an example, two examples here. One, you do a meeting station on a single track line, and one, you have a single track in a curve and you do double track. Why we don't use line kilometers in our planning. We use actual measured meters between the objects. So a crossing station is built. Of course, the 2 tracks, you have kilometer values measured on the points, switches. And you can, of course, not use the delta between to get the track lengths. And we've seen that a lot. It's easy in Excel. Minus and then. And then single track, you build a double track. That's not the case for, it's with, well, it's general. Here, the line kilometer is often not changed, because if you change it in the beginning, then you have to change 300 kilometers for no reason at all. And I know there are people here better in math than me, but the lengths of the green tracks are different, and then it's different to the black track in the green as well. So please use actual train length when you specify your data, how to build up the track in a model. Because, as I said, see it as a train sees it. The train in ERTMS level 2 sees the movement authority. There you know the balise linking list. It's distances. That next balise comes in 1,232 meters. It doesn't stand that, oh, it's on kilometer 132.250. And this way, what we do is also luckily compliant to the model that Rail Topo model is using, that is the base for Rail ML as well. So now I will show you a little short, it's now I'm even thinnerized, it's Robert Eschbach's slides about formalizing our rules. The mission was easy, optimization, verification of the ETS planning data, easy. There is the block diagram. We have the formal syntax, the semantics, formal verification with a model. Eigenschaften is German. I have forgotten the English word, sorry. Properties. And yeah, that's what our mission was, our goal, but we changed it on the way because of data. Because I will look at a syntax rule for this station which I showed before. It should be understandable, analyzable, and testable for machines, not only humans. So here's the station again. Now I have said some names on the points. Here is a syntactic rule visualized in Switzerland. I will not go so deep here because we want to eat dinner in time. As you see, this part here defines if it's a point or slip which, and you have this, and then those are those, and then that gray matches to that. Yeah, it goes like this. And then here is the segment. That is the rule for the point, and here's the rule for this segment. And here you see you have the where FEN again, and then you have if this right means that it's this part of the point, and so here I must say Robert Eschbach has done a major job to formalize this, and we have spent a couple of hours together to describe it. So this is just one of many what we have to see. I mean, for an experienced engineer, it's pretty easy. It took a while to learn, but to put it into the data, to make it formal, it's another piece of work. And then everything builds on this. For instance, if you have a balise group there, then this position is defined by this and the length from this to this. So is this start wrong? Then you remember the big red line row. It's because of the base, the foundation, the node edge model is wrong. Then it's everything wrong. So, and next step, here is, now I go to Christoph Beery's part. If we visualize the rules, the data, the processes today, it's like the Swiss Alps. It's hard. But we want to find a way that are more, this is flat in Switzerland. So we want this simplify, standardize, adopt, it's for all three. And then we want to cooperate. We have sent out the RFE last year, you have answered prover, others also. And then we have from the state, we can do what's called dialogue procedure. Then we can go to the market and say, we have these problems, but we in-house, we, SBB, we don't have the competence, but we want to explore. So we have a good opening there. And our aim is to try different object or say scenarios and try to which match the best. Say this one matches. Okay, it's not perfect, nothing is perfect, but it's the most perfect. And then where then you can see here, if we cut this top, then it will fit better. But then we will get a gap there. But anyway, we have to be open and adopt everywhere. In the data, in the rules, also in the processes. And how do we want to do this? In a huge corporation, because there are so many, on an engineer's perspective, so many involved stakeholders. It's the RailML where we are going forward with full speed. Adopt the rules, the syntax rules, the planning rules, also the formalization of the rules, because yeah, and then the tooling on that, because we cannot continue so much with manual work and also the homemade scripts everywhere that saves a lot of time, but we have to centralize. And also the process, everything, and we're looking forward to cooperation with the academy, for instance, the ETH in Zurich, the industry. We go through procurement because we are SB is an open company. We want to fair transparency. And then we have the validation as well. And on this, I don't want to speak about money, but we have to take care of that too. But now we are more engineers than project managers. So that's fast, but that's all I have to say. Thanks for the opportunity. And questions?
I'm curious if you have experience with migrating data in kilometer numbers to something that you think is more suitable for your applications.
Yeah. I mean, now they are working in Switzerland and measure up the whole system, the network with GPS, and it will be measured. The things you saw in the gray, it's the Swiss grid LV95. It's on the millimeter. But so it's coming more and more into the big databases that handles all the data. So it will be better and better. But I said before about the line, I forgot that, but you don't forget about the line kilometer either, because for instance, for maintenance, it's very important. If they should change a police group, they don't want to know, oh, the police, it's 5,200 meters from the last point. Good luck. They want to know it's kilometer 150, because then they know, okay, oh shit, I have to pass that farms and they hate me, but that's another thing. I don't know if I answered your question.
Yes, you did. Thanks.
Yeah, thank you.
Any more questions? Okay. You said you changed your current standards, your in-house standard proprietary language to RailML.
Yes.
Why did you choose RailML?
Because there are a end of a big new framework procurement for the interlocking the RBCs in Switzerland. And there it's written that SBB wants to have RailML in as data exchange language.
So in fact, RailML will be the new standard for this kind of data?
Yes.
Okay. Is everybody agreed? I don't know. Germany, do you agree? Ah.
Yeah, but RailML is, I don't know how many, it's a good start, but there are gaps and very big openings in RailML that every user from all sides, infrastructure manager and the industry, has to make their own documents. So we see RailML like this, and then you have to match it. And for instance, in the RailML specification, there are not a single word about natural values, and it's pretty important for level 2. So there we have to write a set. So SBB will make an extension file. Here is the RailML, and then it can be hope in the tools matched, or the tools can generate it correctly.
Yeah, thank you. You didn't mention in the call it the big one with all the different ERTMS in the middle. You didn't mention EOLYNX in that picture. What's your ideas on EOLYNX?
Well, I don't work with it. I have colleagues that does it. Sorry, but I'm pretty busy with this. No, jokes apart, that's also part of this procurement of the new interlockings. They shall use the EOLYNX protocol.
Okay,
definitely.
So that will be in the future. There will be EOLYNX in Switzerland.
Yes.
Okay. Yeah.
If you want to need more, I can give you contact details to the experts.
No worries. Okay, any more questions from the audience? Nothing, Kahina? No? Okay. Thanks a lot to Henrik.
Welcome.
And for next speaker, we have Robert Schmid from Germany and System Lab 21. And we will go deeper into the EOLYNX kernels and his world. So please.
Thank you very much. So I brought my own computer and we have switched over. Nice. And I hope the frame rate is correct. Just to check. Okay. So thanks for the introduction. And I would also like to take the opportunity to talk about EOLYNX, which has been mentioned a few times already today. Also to touch on a few aspects that have also been mentioned, including the interfacing between software and hardware parts in the development of systems. Also aspects regarding interoperability of EOLYNX-based components, as well as the handover in terms of processes between manufacturers, system integrators, and the railway operators. So also, I will introduce a new, let's say, proposal offering from our company, which is called EOLYNX Kernels. And finally, I'll be trying to give a first sneak peek or demo into this, which always has the potential of failure, so it's going to be exciting. But let's see how it goes. So just as a few words of introduction, so I'm the co-founder of Systems Lab 21. We're founded in 2021 and are a very small company right now with 6 employees. And we have software engineering expertise. So we are a spin-off of the Hasso-Plattner Institute in Potsdam in Germany. And my personal background is also on computer science, operating systems, and middleware. And since 5 years, I've been now very heavily interested and involved into the German Neupro and European EOLYNX specification works. So as a company, we have 2 main focuses. So on one hand, we provide services and consulting to infrastructure managers such as DB, ÖBB, SBB. But then also we have a product which is aiming to improve the interoperability of ULINX subsystems. And this product is called Platform 21. I will give a short overview in a minute. But just as a first opening question, maybe a quick show of hands, how many of you have actually skimmed through or opened the ULINX specification, so had a closer look at what's there? Okay, so that's a handful. Good to know. So I take the chance to reintroduce the concepts of ULINX to the others. So this architecture, which we have also seen on one of the previous slides or presentations, is the main focus of what ULINX defines. So we have in the centerpiece of the architecture a central unit for the electronic interlocking, and then we have subsystems for the field elements. So the outside plans of the electronic interlocking, which is, for instance, the train detection system, the point object controller, and also object controllers for light signals, if there are still light signals to be equipped. And mainly, ULINX is concerned with the safety-critical communication on the interfacing between the electronic interlocking central unit and these outdoor plants. And also, raster was mentioned a few times today already. So all application-level communication that ULINX defines is based on the generic raster transport protocol, which again is based on standard IP-based communication. So eventually fiber optic or Ethernet communication between the indoor and outdoor plants. So the goal of ULINX is, of course, to have interoperability between these standardized subsystem components. So that means that I could potentially take any ULINX compliant object controller and integrate it with any other ULINX compliant interlocking central unit. And that also brings the opportunity for manufacturers of these subsystems, which could also be potentially smaller manufacturers that enter the market, to provide a single product that fits the needs of multiple European markets and of multiple national infrastructure managers. And as I mentioned, the ULINX specification covers very much the communication part between the two systems, but it also defines the internal behavior of each of these object controller subsystems. And this is still subject to a great variety of national requirements. So, for instance, some countries prefer to use track circuits rather than axle counting for a train detection system. Some countries use 7-wire interface to drive their point machines rather than 4-wire interfaces. And the light signaling systems are completely different in each European country. So this kind of variety and subject of national variations is still possible or also included into ULINX. So our product, just to cover that for a moment, it's called Platform 21, and we're helping developers of subsystems, so ULINX object controllers and interlockings, to ensure that their implementations are conforming to the specification. And we offer a software as a service product, so a software-based product that has a library of simulation systems. So they can be used for hardware in the loop testing or software in the loop testing of the actual system under consideration or that is being implemented. Also, we have integrated the entire stack of the protocol, so including the raster protocol, so you can really do these hardware in the loop tests. And then there's also something like a test case catalog, which is prescribed by ULINX that is used to demonstrate ULINX conformity. And our simulators can be used in this context as well to simplify the automated execution of these test cases. But on the notion of ULINX conformity, there's a challenge with the current state of the specification. So as I already said, everything starts basically with the European ULINX requirements and then is amended by national requirements that are defined by the national infrastructure managers. This is handed over to the industry and as a subsystem supplier. So for instance, a supplier of a level crossing subsystem or a point object controller subsystem or any of the other field element subsystems. We can use these requirement specifications to create a product and then also obtain a ULINX certification. And this certification is based on a successful test run of the ULINX test case catalog, which is published as part of the baselines. So we have a basically a certified product at this point, which also has a ULINX certificate. And now we would like to integrate this into the overall interlocking system. And that's the job of a system integrator as opposed to the subsystem supplier or the subsystem integrator. And here we have a combination of the object controller and the electronic interlocking. And we have the challenge to create a safety case for the integration of both. We ask ourselves a little bit, how does this ULINX certificate help us in this process? Does it make any kind of safety related statements about the behavior of the subsystem? And this is a bit of an open point because essentially the safety or the purpose of ULINX certification is not to make a statement that is in some way safety related. We're a bit left alone at this point where we want to integrate the subsystems that are ULINX compliant into our overall system. So this integration process is proprietary and could lead to requirements that the subsystem supplier must need to fulfill, but they couldn't have known it before because they didn't know who would be the eventual integration organization for the specific national project. So this is let's say a challenge in creating a single product that is fit for multiple markets in Europe today. And there's a risk involved here for the subsystem supplier because these requirements are not known in advance. So our approach and our proposal is to use, let's say, a formal methods-based approach to help out. So we again start with the current state of the ULINX and national requirements, but then from that we would first derive a standardized behavior model of each of these ULINX subsystems. And that is defined in a formal language that is, you could essentially think of it as a software definition. And that is not specifically bound to a particular hardware implementation, but it gives enough information to carry out a generic system integration process based on the formal model. And so we can already kind of do this on the generic level and create evidence for system integration based on a generic formal behavior model of each of the subsystems. So this model would deterministically describe the behavior of each point object controller, of each light signal object controller, and so on. And now with this, what we call ULINX kernel, we can go ahead and create a compliant subsystem implementation again, and that would be, again, the responsibility of the subsystem supplier. And what we can do here at this point is to formally prove the equivalence of the implementation with the formal behavior model. And that allows us to, in the following integration process, rely on the generic integration evidence, which was already carried out based on the formal model. So whoever is integrating the systems can already make use of this generic evidence before this product has even been created. And once we have actually these products available, then these two artifacts can be combined to carry out with the actual safety case. But most of the integration steps have already been carried out on the generic level here. So that's the idea of ULINX kernels, as we call it. And it helps in system integration, but also fulfills the second purpose. And since this is the design automation forum, we envision them to also be used to create the actual implementation code, which is going to become part of the subsystem product. So for that to be possible, we will have to qualify these behavior models as a software artifact according to the safety integrity level 4 and the according standard. And we also have to think about the interfacing between the software artifact and the underlying hardware platform. So this is what I call the virtual platform interface. So also that needs to be considered, and I think it can be rather slim and can be rather generic. So for instance, it's also suitable for PLC-based platforms. But this is going to be part of this, let's say, partial safety case, which is going to be created for these behavior models. And using these models, we can then also create a generic pre-assessed SIL4 artifact that is to be used during the system integration in the context of different national markets. So with this introduction, I would like to switch over to a demonstration of how this could actually look like. And in this specific instance, we've been working on a prototype which is mapping the functionality of a point object controller and is using the new ANSYS SCADE1 modeling tooling. So ANSYS SCADE is a widely applied formal modeling and let's say implementation directed modeling tool, which is applied in the railways, avionics, and many other domains. And this model covers essentially the ULINX level application logic. So it has synchronous semantics, it is deterministic, and it also is suited for formal verification. And then in this demonstration, we are also looking at the part of the system that is beneath what I call the virtual platform interface. And this is provided by our Platform 21 execution platform, which provides the raster functionality and also provides some simulation of I/O interfaces that we use in this case to simulate the response from the point motor or the point machine. So this moment, I'd like to switch over to the model, which you can hopefully see. And I just want to give you a rough overview of how this application model looks like, which is now defined in the new SCADE1 engineering product. So you can see data flow and data exchange between different control blocks, and everything is deterministically translatable into software code. So ANSYS is providing a translation into C code, but the semantics of the model could as well be translated into something that is directly suited for PLCs. So to just drill into one of these state machines that are behind these control blocks, we have one control block that is responsible for observing and controlling the current point position. And this is highly inspired by the state machine diagrams that ULINX has already created. Those are not qualified in any way, but this modeling fulfills deterministic interpretation semantics and leaves essentially no room for interpretation. So this is what we have created so far. So it has three states essentially. One is just for detecting the current point position, one is for driving the point to the right end position, and one is for driving the point to the left end position. And on the other hand, to just give you an idea of the coverage of this model, we also have a state machine that reports the current point position as part of, in terms of a ULINX telegram to the electronic interlocking. So you can see how we define the ULINX compliant message as a struct in this modeling language. So in order to show you this system actually live and running, we need some counterpart to test it and to drive our point machine, which we simulate here. And for that, I'm going to be using our Platform 21 simulation product. And we have just created a very easy way to import a specific object controller configuration into our system, which is essentially encoding all its configuration values into this single QR code. So since I can't scan this QR code with my computer, I can just follow a link that has the same kind of meaning as the QR code. You could stick this QR code to your physical devices and then just scan it in order to interface with it. So if copy and paste is going to work, I'm going to open this link up in my web browser. Okay, it has already opened a few times. So now we're in this Platform 21 product, and it asks us if we want to add this configuration as a digital twin that we want to simulate, or if we want to create a communication counterpart. So in this case, we have an object controller, and we would want to have the electronic interlocking simulated by the system. So I'm going to add this counterpart configuration, import it. And as you can see, this has now included all of the configuration variables for the raster protocol, as well as the ULink specific configuration options, which are specified as part of the standard. So in order to now show this live and running, I'm just going to run a little local executable and start the simulation of the interlocking. Okay. And as a second step, we can actually run our skate model, which has been translated into C code and is executed, as I mentioned, as part of our simulator runtime environment. So this is happening using this command. And now what we can see that is within a few moments, we can see from the perspective of the interlocking that our point machine actually reports a position, and that in the background we already have a ULinks communication running. So when I look at the network debugger, you can see how the raster packets are exchanged between the two systems. And if I go in and command the point to right end position, then you can also see how the respective point position messages are exchanged via raster. So this just exemplifies how far we are actually, and how we imagine how these ULinks kernels can be modeled with deterministic semantics in SCADE 1, and then be part of an implementation that makes use of commercial off-the-shelf hardware. So in terms of also, let's say, the open signaling initiative, I think defining this virtual platform interfaces between a piece of a railway application software and the underlying execution platform is a critical point. This is one way of how we envision that this can be done. And also the proposed model has the mentioned benefits in terms of system integration, and that we can create pre-assessed artifacts for integrating any ULinks object controller that is compliant with this model, and that gives a certainty to anyone who is implementing such a subsystem, and is enabling them to serve a European market with a single product. So with that, I'd like to conclude, and thank you for your attention.
Questions? Thank you, Robert. Any questions? Yes, we have questions here.
Hello. On the slide, I think it was the slide you introduced the kernels, the term.
Yes.
Terminology. Yes, here. So you have like the upper behavior model. And the lower one, which is the actual implementation of the object controller.
Yes.
And you want to prove that both must both be in a formal language like SCADE, or?
Yes. So there are different techniques of how to actually prove and automatically prove the equivalence of two, let's say, formal behavior models. I think SCADE per se does not support this sort of checking operation, but Prover has tools that very well support this based on HLL. So this could be one option to accomplish this task.
Okay, so and then I guess my question is, can't you always? I guess not, but can't you always just use the upper one as the implementation, or I guess that's not how it works, but
well, so the idea is just also to use the upper model as the foundation for creating the implementation, which I consider to be somewhat specific to the hardware platform that you're choosing. So if that hardware platform supports, I don't know, C as a target language, then some translation step would happen between the SCADE model and C. And if the hardware platform supports the standardized PLC programming language, then that would be a translation step. But in terms of, let's say, the application level logic, I think all the relevant behaviors already contained in the upper model.
Thanks.
Question from an online attendee. Does ULINX also define how object controllers work?
So that is part of the specification, and this is also part of what is tested as part of the ULINX test case catalog, but it is not given in that as a SIL4 certified software artifact. So it's more informal and it's semi-formal. There are state machine models contained in the ULINX specification, but those are not directly suitable to be used, for instance, to make any justifications in terms of the system's safety.
It seems to me that in a safety case, you have to take into account what kind of switch motors you have, for instance. What would be the suitable program for controlling the switch? How does that fit into this picture here with the formal models?
Mm-hmm. Yeah, that's a good question. I think we have, in terms of, when we take the example of the switch motor and the point object controller, we have a pretty well-defined system boundary, which is the standardized. In Germany, we have a 4-wire interface. In other countries, there's a 7-wire interface to control the switch motor. But also there's a, let's say, hardware safety aspect related to the relays that are used to drive the switch. And so also the fault model and hardware-related failure aspects need to go into what is what is defined as part of the upper model in this picture. So we must make certain assumptions on how the hardware will behave in case of failures, and these assumptions must be fulfilled by the subsystem supplier as well. Yes.
Hope I'm not wrong, but in your demo, so there is an interlocking logic which is connected somehow, right?
So the interlocking logic is just controlling the desired state of the point. There's no, let's say, route logic implemented as part of what I just showed in the demo.
Okay, so my question would be in this slide, maybe. What you called a safety case would be a generic safety case or a specific safety case. Like, do you think it's possible to reach the level where we have enough information at this level using only these models to come up with a specific safety case?
So I've discussed this concept with an independent assessor in Germany, and I think what we could agree on is that it is not necessary when we want to make statements about the behavior of the point object controller subsystem. It is not necessary to understand the entire route logic that is going to be connected to it on the side of the central unit. So the parameter or the configuration space in Ulinks is quite limited, I would say. So you have, for instance, you have different numbers of point machines that you can control. There are different protocol parameters that you can set, but I think it's feasible to come up with a generic safety case that works for all possible configurations of the object controller subsystem, so that you do not actually need any reassessment depending on your specific site.
You okay with that, Benjamin? He's thinking. Let's see. It will pop up another question. Someone else? No? Benjamin, have thought enough or no? Okay, good. Okay. Thanks a lot, Robert, for the interesting specification. We got some formal method stuff here, so I know my colleagues loved this. Thanks a lot for your talk. We're about to end this session, and we are about to have coffee break for another hour, and we should be back at, where are we? 4 o'clock. 4 o'clock. Yes. So thanks a lot, and after break we will step into the domain of AI and open up for a completely different perspective how to work with a signal system. So thanks a lot, and please enjoy coffee break and exhibition. So we are back again, back for the last session of today, and I hope you enjoy it. It will be about AI. We will do a presentation by Faye, and then we will do a panel discussion talking about today's topic. But first we have Faye from Prover talking about AI innovation. And always when he talks, there's something new happening, because I think the AI is moving a bit too fast, for me at least. But please go ahead, Faye.
I guess you can hear me. Yeah, thank you. So the title of my talk, which is not written here, is Scaling Safety and Formal Methods and AI for Railway Control. So obviously, maybe in case you don't know, I'm not really one of those annoying AI fanboy mumbling about buzzword every day about AI. Have been working with the formal methods and rail for many years, so I'm one of you guys. So you know, so we Prover we're thinking about AI very carefully and investing it very seriously, because we do see a lot of potential and also synergy between AI and formal methods. So I will also do some quick demo of one of the things we have been working on. Yes, I have to use this one. Yes. So AI, yeah, of course. AI is here, but AI over the years has been referring to quite different things. In the 1980s, has been more on the logic-based, rule-based systems, and gradually it evolves into mostly neural networks or artificial neural networks, and also deep learning there's many layer deep neural networks, to put it simply. And also, as you can see the picture here, it's basically a history of the development of AI. So it started with this is do you know what is called the first one? AlphaGo, and also the second generation AlphaZero, which was like probably 2015. That's one of the first successful application of deep learning, where they have developed this AI model, which can play Go so well and beat all the human Go players. And in the second generation, they have optimized it to have the AI to learn how to play this game not only Go, but also chess or similar games from scratch, which means humans don't teach anything about this game, except the result, of course, win or lose. So let AI figure out what kind of strategy or tactics needed to win the game. So that was really a groundbreaking research, which inspired a kind of directly, indirectly inspired the second one, AlphaFold, which also from DeepMind, the company, which was, so they used end-to-end neural network to predict protein folding. So I'm not an expert in this at all, but you know there are the strings, the DNA strings of acids, and so when they fold to form some certain 3D structure which represent the information, but it's very hard to know what kind of structure you can have from these strings of acids. So then the same company DeepMind, they have discovered this using the AI or neural networks to predict this, which actually was so groundbreaking. So they were, before this method, there are already other existing older, more rule-based writing software kind of methods. Takes years to finish one task. For AlphaFold, and the first generation and second generation, it takes days, hours. So it's really revolutionary. So then people started to notice about this piece of technology. And it's actually very useful, and also kind of people outside this community started to notice this, because this technology can be used to predict, to investigate some kind of virus like COVID. Like within days, they can kind of study the structure and also understand their certain characteristics. So a very important piece of technology. Also, and the second generation of AlphaFold started to use attention or transformer technology, which actually gradually evolved into ChatGPT, a language model, which was, of course, kind of almost everybody has heard about ChatGPT and has probably used it. And this is the moment where this piece of technology has evolved into the stage that everybody has started to be aware of and affected. Yes, that's basically how. So nowadays, when the people talk about AI, it's basically language models or neural networks. People started to forget about other things. So maybe, and so like the Prover's technology, 20 years ago, it was also AI. But of course, we have our own unique edge or problem to solve. That's why we think the technology are complementary. Okay, let's come back to that later. So what's special about language model? So the models before language models, they were really specialized. They can do one thing and one thing only, kind of one category of things at least, very well. But it doesn't generalize. And for example, the AlphaGo can play Go well, but it doesn't talk to you, and so on. So it's very specialized. But until we have language model, a language model, because the language model is trained on language tokens, whatever you call it. So that, but because language is such a special tool, so it's ultimate tool, because it's built to generalize by design, and people, human, use languages to think and learn and communicate about almost everything. So you can see people say the language is the word, but of course, to be more neutral, that language shapes the word, because you have natural languages, people communicate with each other with natural languages. You write your programming languages, code in programming languages, general purpose or domain specific, or even you have mathematical languages, like formal languages that works a lot with. So those are all languages. So if you can have an AI model can understand the language and can generate this language, that's really very general capability. And also people have found a way to compress all human written language knowledge into this neural network. So it's large, so that's why called large language model. It's very large because it basically used all written data languages you can find on the internet or anywhere. And those companies who made the models, they take, they go very far to get all the data that they can get to compress into the neural network. So the takeaway is that lots of people believe that language model gives us a credible path towards AGI. It's artificial general intelligence. So you people have been dreaming of having AI models who as intelligent as human on all aspects. So that's AGI, but also some people don't really care about this, but they also want to have something else called ASI, so artificial super intelligence. So meaning they want AI models are super good at certain things, certain tasks, but they don't care about if the AI models can do everything well enough. Okay, so this is the kind of bit of context. So very quickly mention that. So what language model mean for us, for everybody here? So as ChatGPT is probably the most known example because it has been the fast-growing consumer app ever because it received 100 million users within 2 months of launch, and nowadays it's 700 to 800 millions weekly active user. So it's really popular. Everybody use it almost. I'm surprised if we have people here haven't used it at all, but let's get back to that topic later on. So language model, they are so influential because they are not just a tool. They are kind of changing the paradigms of interaction. So how human interact with anything else, or human interact with each other. So there has been so much progress, and of course, it's basically has been shown that the language model are so good at text understanding, vision understanding, information ingestion, and content generation because you can generate videos, images, text, of course. For example, OpenAI released the Sora 2 yesterday, which was really there's a really big progress has been made on the video generation, and also math coding and web research and so on and so forth. So yeah, it's fair to say that language model have been in fact affecting everyone across every domain. Yes, that's a bit of context. So why Prover cares about AI and why we're working on that? Because we care about automation. So with the formal methods, we are doing automation. It's actually also known as automated reasoning. So AI can bring different kinds of automation. And that's why we care about AI. And also in the railway business domain, it's really requirements intensive. So lots of text, documents, lots of efforts put into requirements, specification, analysis, and validation, so on and so forth. That's where the area where we believe that language model can be very helpful. And also vibe coding. There's a huge progress on using AI to code. And of course, there has been a lot of successful stories like tools like Cursor, Lovable, Devin, Codex, Columnar. It's a very long list. So they are making progress every week. Every week, there's some new tool pop up. And we think maybe it's worth our effort look into this direction, see if we can have AI-assisted formal modeling. And also we, as I mentioned before, there's synergy between AI formal methods. I will go into more detail later on, but briefly speaking, we believe that AI can lower the barrier to the formal methods, and also AI needs formal methods to be trustable. So we have a slogan: engineer a safer world. Now at scale, hopefully with AI's help, we can do more projects, make something like that. Yes, I will go through this last slide before I do a demo, because I want to. There's some kind of more concrete statements on how we think and formal methods need AI, so to speak. Of course, I mentioned that use language model AI to make formal methods easier to use, because the first one is to analyze input documents and specifications to extract formal models, and because formal methods need input, and those inputs may be in most cases they are documents, natural languages, tables, or diagrams, and so on. And the first step, often where you need to look into this huge amount of documents and trying to kind of extract relevant information, requirements, segments, and so on, before we actually started doing formal methods. So this step can be very manual and slow without AI. And second one is to actually use, when it comes to formal methods, one of the things that people can kind of complain about, of course, is to work with formal methods, it requires pretty deep knowledge or expertise in formal logic, which is not really common. And so we think this can be helped. AI can be helpful here in this regard, of course, and also guide the user through our process and help. And the fourth one is also very important, because when you work with more formal methods or formal verification, when our formal verification tool tells you, okay, there's a counterexample, your requirement is violated, but this is and this process has been a challenge for some of the users to, for example, how do you interpret the counterexample from our tool to map to the real world scenario and to understand it, how exactly a requirement is violated. And this process is also been one of our bottlenecks, so to speak, in our process. So again, so the last one, of course, to produce documents and reports. This is where the language model are very good at. So as a result, we hope to see that it will be less work to set up for a new application or client, and also so the client can work more independently from Prover. So they can, because the less formal method expertise are required with the help from the AI. And also it's easier to analyze the result and draw conclusions. That's also very important. So this is one part of the story where the synergy, where we think that we really, as a formal method focused company, why we care about AI and trying to work on that. Yes, so I think there was this one. Yes, there will be demo, and this is this picture is our kind of very kind of capture our process in terms of tools and phases. So in the first phase of our Prover design automation process, we work a lot with the Prover Studio, where we develop our formal specifications. And as you can see, it can take months to have some kind of formal specification. And the rest is become more and more faster, and with tool support like iLog and Prover Certifier. So this seems to be seems to be a room for improvement. So that's why we add in the AI robot here. So we start here. Demo is also about this. Okay. So you don't see it, of course. Should I just here? But I don't see it. So maybe I should duplicate this display. Now all of us see it. So this is the Prover Studio, and as you can see, maybe it's too small for you to read all the detail, but I can tell you this is where we have to write our requirements, or rather safety properties to our system. And for example, this is our model, formal model. It's not like a diagram based. It's texture based. So for example, there are we're trying to prove some properties, like if signal is commanded to proceed, and then one of the following conditions holds, and then we write it in the form of logic formula. And this is how we work with when we say we formalize our requirements, right? This is kind of typical interlocking principles that we have our requirements from. So you can see that okay, there's the to do here. This is not done. We haven't formalized this requirement. So instead of writing it manually, we can see, okay, Prover 1 is our kind of internal AI assistant that we have access from the Prover Studio. So we can ask, okay, so please, we don't have to say please nowadays. You don't have to be so polite. So formalize the GSS. We can give the formalize based on its description. Formalized, yeah, I think that's good. So you can see there's a lot of going on. As I said, you have to, I've explained this a bit later. So there is kind of process of a workflow, whatever. There's some kind of steps in order to make sure you have a relevant and actually a correct result. So then you can see, okay, this is the our result. I hope it's right. Yeah, it looks right. So now I just say, okay, this is the, I can ask you, okay, add this formalization back to the file. Okay. So you see, this is the kind of new kind of interaction you have with AI. So you don't have to, you can just talk to it. It might not be the best way of working, because there will be better ways people are working on. But I'm just showing this kind of basic change that AI has brought. So you can see, I've asked the AI agent to put back to this formalization to the file where there was kind of a to do. So you have the chance to see the difference. Okay, looks correct to me, so I just check. Okay, good, edit, and okay, sorry. So something. This is okay. This we just asked Approval 1 to add, try to formalize the requirement. Okay, so and maybe something else I can show here is to, you can notice there are some requirements don't have descriptions like this, and there's probably, let me check. Oh yeah, there's 2. So I can ask Approval 1 again. Okay, add informal description to the requirements that miss 1 in the file. So now, Pro 1, we are looking into the file and see, okay, what requirements miss the description, and come up with the description. Yes, so in GSS 3 didn't have 1, so exit 1 didn't have 1, and there's 1. Exit 2. Okay, that's the input. Add this description back to the file. Okay, you can see that in this editor, we have seen, okay, those text has been added back to here. And also you can, again, you can just, okay, let's keep it. Yeah, so this is how you would work with AI. But of course, there's more there's even more, which I will show you later, but not with demo, but just some vision about it. And yeah, maybe it's enough for the demo. I don't know how much time we have. Yeah, 5 minutes, yes. Okay, let's come back to the presentation, because we do have something more to talk about. And yes, so, oh, not here. Extend. Yeah, so I just show you here. So we put a little AI robot here. Of course, this is just the beginning. There's a lot more going on, and there's a long roadmap we are trying to work on. Yeah, so just some notes. So you can see that it's safe to say that the state-of-art language models are very intelligent or capable, smart. So they can do a lot of things. They can win the gold medal of Olympia math competitions. They can do scientific research, come up with the mathematical, do maths and whatever. So, but keep in mind that we need to manage our expectations, because if you just say in the prompt that, okay, build a super safe system that runs flawlessly, it won't work because you didn't give enough context to it, right? So, and also you need it's actually a skill to work with AI. So you need to know some kind of, because language models are pretty sensitive to the prompt. That's why you had this term called prompt engineering, but now we have a new name. It's called context engineering. So because for AI to work, often you need to break down tasks into small, well-scoped steps. Also provide the right context at the right time to the language model. And also you probably want to have long-term memory and continuous learning capabilities, because currently language models don't. They are stateless. So every time you talk to it, it doesn't remember the previous talk conversations. You need to build the stuff around it in order to have long-term memory. This is very important. It's not only for learning while working, but also a personalized experience. For example, if you use ChatGPT, it does have memory, but it's something you built outside the language models. Yes, so we have seen that this we call scaffolding. So you have you kind of orchestrate and build things or guide the language model, which you can accomplish a lot. You can really have AI that can really demonstrate deep domain-specific expertise. But that's our observations. But also people are also talking about agents. Because you have seen that when I chat with the Pro One, so I have one kind of one-to-one. I have to tell them exactly what is the next step or what I want. So this chatting thing, some people don't like it because they think, okay, why not just let it run autonomously? And of course, people have been working on that. So this is a lot of talk and kind of buzzword, so to speak, of AI agent. So in the simple term, agent is like some kind of a language model which has a brain as language model, but also memory, and also it has access to your domain knowledge. It has access to tools like provers tools or any tools it can use. And it runs in the loop, and that's it. That's agent. But of course, sometimes you do want human in the loop, and that's actually often the case where you do want human in the loop. This is the way to actually, to put it harshly, it's a way to exploit language model, the AI, because you can leave it run overnight, and in the morning you receive a report, a progress report about things he has been doing. And the state art of coding agents can run autonomously up to 30 hours without any stop or human intervention. And so that's pretty impressive. So with agent, you don't really need to chat with it. So you just give, either you give a simple prompt about, okay, please do this, something like that. And it will start to investigate or guess or trying to collect information from the web, or trying to use the tool to get feedback of the things he has produced and started to chat with itself. Not instead of me chatting with Pro One, it's chatting with itself and to figure out, making the plan, do the next step, and figure out the action and take the action and get the feedback and so on. So it runs autonomously. Or you can give a relatively detailed specification, but in natural language. So you can give more information if you want. So it depends on your ambition and the projects, of course. So, but that's exactly what people have been working on with, especially with the coding agent. But also, when I say coding agent, the coding agent has evolved into a pretty general agent, because if an agent can code, it has probably the most access to the digital world, because the code is the best tool to talk to the digital world, right? You write code, you run it. That's how digital world works. So the coding agent will someday suddenly become a very general agent, and not just write code or run it. But this is pretty hot spot nowadays. Lots of money put into like a Swedish company, Lovable, and so on. So that's the thing they are working on. Okay, so we don't have time. The last point where, of course, we, and as prover, as I explained, I'm not like one of those AI fanboys. I start from the AI. So we think, of course, how AI actually AI need formal methods, because AI is very inherently non-deterministic. It can hallucinate, can make errors, and so on, like humans. And there's challenges, of course, when you use AI for example, generate code and generate documents or any other artifacts, or you actually use AI as a component in your system. So you basically put a piece of neural network in your system. That introduce non-determinism. Maybe AI can be adversarial to your system. So that's a challenge. But in this case, we think the formal methods have become not obsolete, and on the contrary, it's become more relevant because formal methods bring the greatest level of rigor and determinism and trustworthy in this setting, and more than any other approaches. And also, formal methods has been considered to be probably the only way to enable AI in a safety critical domain like a railway or solving complex problems. So formal methods is really required. So the takeaway is AI unlocks new capabilities, but formal methods make AI safe to use. Yeah, that's my talk, I think. We have Prova Labs, and we have trying to do different small apps in different directions, and we have a web page called Prova Labs where you can get access to the apps, and also part of the work was funded by Autodata and Traffic Record, just for your information. And yes, thank you.
Thank you, Faye. Thank you, Faye. Very well done. Like I said, always something new and listen to you. I don't know, AI is moving faster than my brain, so that's where I go. I like to have the speakers on the floor, please, on the stand here. So join for a small chat to summarize the day. So please, Fredrik, Juma, Andreas, Robert, Henrik. There you go. And Jesper, perhaps. Where are you? Where's Jesper? There you are. I don't know, did we have any questions from the chat? No. Do we have any questions from the audience to the Faye? Good. Thank you, Björn. Thank you, Björn. Yes, please take the, yeah, all the way. Good work. Faye, you have to answer Björn's question here, so.
My pleasure. Or I can ask my AI to do that.
Do you hear? Yeah. So, I have a question about the Prova 1. All AI are hallucinating, and how have you configured? Like if you have a requirement, and maybe I've written it and come up with something wrong, then I give it to the Prova 1 and says, can you do the formal requirement for it?
You mean the requirement?
Does it say I can't do this, it's impossible, or does it try to make something up?
Oh yeah. Yeah, I mean, there's chance that AI can hallucinate, as you said, if you give it the wrong information on the start. So then you probably need first you need another AI to make sure the requirements are correct, the informal one, and of course the AI doesn't really make it worse in a sense that if you have your input wrong in the first place, it's really hard to do the following. And also the good thing about formal methods, to have formal methods in the loop, is that formal methods are very rigid. It checks things very carefully, and we have a whole machinery to make sure that whatever errors you make, it may be very likely to be caught, of course. But then there's of course the cases where you have the wrong wrong information from the beginning, and no one. In this case, of course, nothing, no tool can help you with that kind of problem. But as I said, maybe you can have another AI there. Yeah.
Thank you.
Yeah.
Thanks. So thank you all for having us and listen to you guys. It's been an interesting day, to me at least. Hope you have some value from you in the audience as well. I have a few questions for you guys, or I can actually ask if there anyone in the audience like to start. Questions for the panel, or what you have heard today, listen to. No? Okay, I start. If we continue with the AI stuff, someone like to comment, what do you think and how do you think AI will affect the signaling domain in the next 5-10 years? And what are the risks? Anyone like to catch that one? Fredrik.
Yes, AI will be world changing, of course, in the software development, verification. We will move even faster, but it's the security and the cyber requirements is very harsh, and we need to evolve that very carefully. So we do it wisely, I would say. But yeah, we are experimenting with AI every day, but we are sort of limited by the security, safety, cyber demands, I would say.
Yeah, so we need to overcome that barrier to be more productive in terms of.
Yeah, yes, you can make giraffes, but coding is another thing. Yeah,
that's good. Someone else like to comment on that? No. Okay, we talked about all the morning about open signaling, and we see a start here of building an ecosystem around the open signaling and how to drive that. So the question is, how could we collaborate to build a signal ecosystem that's open, safe, and sustainable? Henrik, what's your ideas on that?
Well, first, maybe open up everything, open source all requirements, and because as I've seen it, everyone says that they're so special, railway is so special, but it isn't. It's just stop and go. And in a way, because as I showed, I know in Sweden, many other countries, everything shall be rolling out in 40 years, that we need to cooperate. And one way is open up the rules and help each other and help AI maybe make like chatbot rules where you can compare similar rules between Sweden and Switzerland and something like this. Just one. I have more, but
more for sure. Someone else like to comment? Jesper? Robert like to comment, please.
So I just want to also stress your point. So I think also during the discussions during today, I think what we are maybe lacking a bit in the railway domain is this ecosystem of common tools, of languages, be it specification languages or formal languages, or the specification models themselves. So there is no, let's say, publicly available body of knowledge that we can all refer to, and also make it easier for new people to enter this domain and to be productive within a short amount of time. So I think aside from establishing tools that fit together and let's say a tool chain such as the ones that exist in the automotive domain, for instance, it's also about being open and sharing and having a agenda for how to train our staff and the new everybody who wants to enter this domain, I think.
Yes, I think about the scientists, how they work. They work at home and they are writing reports which are valued by other scientists, and they discuss between each other, the results and the ups and downs and so on. And I think we could do the same in the railway sector, to share our knowledge and our results together. Because every one of us think that our railway is so special. It's the own type and so on. But we have a lot of things common together, and we can share a lot of knowledge from our different views. And that's a strength for the business, to do it together.
Thanks.
I also have a comment. I think it's still a lot the case that infrastructure managers, they don't request open signaling systems because they don't understand that they exist. So you can't ask for something that doesn't exist. But on the other hand, the providers or the market will not create anything that there is no request for. So we are kind of trapped in this. So the necessary engagement must come from the infrastructure managers. And I was thinking what Jan said before, that what made this happen in other domains was that the end users actually requested it to happen. Was they were open with this is something that we think is important, and then things will happen.
Henrik? No? No, okay. Thanks.
So we need to invite more infrastructure managers to these events.
For sure, for sure. They are bound by budget and things, so, but they are online, I will tell you. Yeah, sure. Great. So, and Jesper, you're trying to build this ecosystem of partners. What's been the most struggling in that work?
Quite frequently, I first meet enthusiasm, but some have hesitated to join because they don't want to. They might have customers that would not benefit from this, so they don't want to be too visible in this ecosystem. That is maybe the biggest challenge currently. So if you look at, I forgot in my talk, by the way, to mention the URL in the end, but there is opensignaling.org. You can try, and you will find a few there that have joined, which is very nice. But I hope to have more. And this is a little bit of a struggle that it can, some potential collaborators, they think that it will not be well received by some of their customers that they do this.
Could I continue that question for Henrik? You are not SBB, but you are very, very close to SBB. And I hope you could sort of see how would you approach SBB for talking about open signaling?
I don't really know, but hard question to ask. But I think in Switzerland in general, there are lots of other infrastructure owners that have small branch lines, and they don't have the volume to procure these big mainline suppliers, but they are vital for the society in Switzerland to run this line that are 10, 15 kilometers long. There I see an opportunity for this. But in general, I think it's also a way to go with open source, open platforms, plug and play. And as TUV SUD, I must say, I've avoided everything with assessor and ISAS, but these processes has also to be more open or not so much bureaucratic, but that difference between countries as well. It's everything. It's a culture change of everything. That's the biggest structure.
Yeah. Fredrik, may I ask you as well? You're a stakeholder. In your presentation, you took both the role as a system and integrator, and you also took the big picture role. So how would you act if you're system integrator or if you act as a complete supplier? Sort of, how do you approach the open signaling initiative?
I guess in the next 5 years, we will work. In the next 5 years, we will work as today, I would say. And then we will carefully be close to these initiatives and support them in any way we can. And also looking at these regional lines where we are focusing and also channeling our offerings towards them. And then I am convinced that this will mature over the years. And then we could segment later on.
So it's about taking the first steps and then steps further, and it will evolve. Yes.
Yes.
Yes. Good. Good. Someone else like to comment on this? Okay. That's more or less my questions. Do you have something from the audience? Thierry, good. Someone wants to run? Alve? Oh, Thierry is running. Good. I will not jump down.
The first one is for Faye. So you say that the AI can make errors. So can AI could use formal verification to avoid errors?
Yes, I mean that's the whole point. Having if you ask AI to generate a code, and of course there's a chance, and if there's any error has been introduced, it's just like a human engineer would do. And then there's a lot of moving parts, right? You have to make sure that to use formal methods, of course, then you need to have really good control of your requirements. To make sure you have, we have our program has already have our own process to make sure that you have captured the right requirements and the good methodology to make sure you have your complete set of requirements, and then you formalize them. So in this process, and if we're gonna use AI to assist, it's still unclear how we make sure that we have this process and fully automated by AI, but we can definitely get a lot of value already by having AI sitting aside and to automate certain things like more routine and repetitive things, but have humans still in control of things. So then when you have your requirements right and formalize the right, then you can make use of the formal methods or formal verification tools to make sure the rest of the code, the code of your system is safe, and no matter how the code is from, right? Your code could be still manually written or generated from some model, or you have your AI agent, a coding agent, to write your code. Then we need to argue that formal methods has served as a they call it guardrail, make sure that that it's safe. Right. So formal methods would be critical in this sense. I don't know if I answered the questions, but
yeah, thank you.
Yeah.
Maybe the second question to Henrik. It seems that ABB at some point had some initiative to use formal verification, and as far as I know, they stopped at some point. Do you know why? Is it a problem of budget or other things?
Why SPB and formal methods and formal work? Well, I'm sitting here. It's a combination, as I showed in my speech, bad data. The data is too bad, and SPB is still suffering from COVID economically. So we're trying our best to clean out the data so we have a good foundation, and then the aim, as I said in the presentation, we cannot continue manual or SPB. We have to go automatization, and we have the case for formal method and formal verification as the first row to test when we have better data and more money.
Thank you.
Maybe it's a question for Robert or maybe Jesper. So I think I've heard this problem discussed at some point that so like if we want to have this loose coupling between software and hardware, is it a problem that if we write a software and it's checked to be safe or whatever, and then it's compiled, and is it a problem that this part that there's maybe not guarantees today for this compilation, or so is it a problem and is there a solution for that problem?
Sorry, could you repeat the last
So,
part
like,
of the sentence?
So is it a problem for this open signaling thing that we don't have guarantees, or maybe we have guarantees for the compilation, like can we write code and then don't care how it's compiled?
Okay, so I think if you look at it from a systems point of view, I think you have to you already divide between hardware and software based on your fault model, right? So the standards say that for the software part, you only consider systematic errors, and any random faults only occur in the hardware part. So when you just look at the software in isolation, then there's procedures for how you can qualify your transformation tools, which is let's say a general term for compilers that might be used to receive a safety critical valid artifact out of this translation process, given that you have already provided a valid input. So I think in terms of, let's say, providing and developing tools that meet these criteria, that's nothing particularly new, and these tools already exist and are depending, of course, on the specific languages that are used, but that's not a conceptual problem to come up with these tools. I think on the other hand, there are certain requirements for the hardware architecture put forward by the 5129 for the SIL4 integrity level, and when we want to make statements about how our software should be used in combination with certain hardware, then we must make an abstraction of what hardware architectures are going to be suited to run our software, and that also fulfill the necessary criteria from the standards. So in general, that's also possible because, as you see, we already have SIL4 capable hardware. It's just that we have to maybe strictly define what criteria from a safety point of view have to be fulfilled by whoever is putting software and hardware together and needs to check for the compliance of the two. So I think there's no general barrier to achieve this sort of decoupling between some software part of the system and then an abstraction, and then some hardware part which can be exchanged.
Thank you. I think, Kahina, you had something from chat.
Yes, so we have a question for open signaling. It says in developing countries, given Vietnam as an example, where signaling expertise is limited, managers often prefer closed turnkey solutions from major suppliers. Because even if they see the benefits of open signaling, they feel unable to control it with limited staff. Then the question is, how can they still adopt open signaling, and what reassurance can show it's a safe and sustainable solution?
That's a good question, actually, and I'm not sure to begin with that open signaling is for everyone. There might be a reason to not go that path. I think Andreas and Kristina mentioned that this choice to try and be in charge of this project, they are aware now, Trafikförvaltningen, that this will come with a responsibility, but it also requires the organization to learn and to become experts in this, and this will, in the long run, give some control. And of course, if you don't have the staff for this and so on, I understand that it's very tempting to just buy something turnkey and have someone else handling all that. But you will also live with this system for 30 or 40 years. So you will also be dependent on someone else in 30 or 40 years. I don't know this particular example, but I imagine that there is an ecosystem of engineering firms everywhere in the world, local engineering firms that could learn to handle such systems. So I think everyone should seriously consider if it wouldn't be a good idea to have something open that can be maintained by engineering firms that you trust in your own country, rather than buying something ready-made that will lock you in for decades. Just an advice to consider it. I understand if the final decision will be something else. But...
Should I hand the mic to Anders perhaps, and I welcome you up, Anders?
You can go ahead.
Should I go ahead? Okay, it's my pleasure. Any more questions out here, or any more comments from you guys? No? Okay. And I think we're on the last slide for today.
That's my computer.
Ah, it's your computer, sorry. Now it's last slide. It's about just saying thank you a lot for the speakers to be here and to present, Sean as well. And thank you for all the good interactions with the audience. And I hope you online have enjoyed the day. And I look forward to speaking about this in the future as well. So thanks a lot. And I wish you all a pleasant evening.